learning libraries as well, like scikit-learn, TensorFlow, PyTorch, right? Thereby allowing for end-to-end data analysis pipelines. Now let's see what are the preferred integrated development environments, also known as IDEs, that are preferred for the data science course. So over here, the IDE is a software application that provides a comprehensive and integrated set of tools for software development. IDEs are designed to streamline the entire software development process, right from writing and debugging code to building, testing, deploying applications, everything in one single go. First, Google Colab. Google Colab is a cloud-based platform from Google that provides free access to GPU resources and pre-installed data science libraries as well, which includes pandas. That pandas would be the most widely used for in our course. It also allows for collaborative data analysis, provides cloud-based resources for computationality, intensive tasks, and supports integration of Google Drive as well. Anaconda. So Anaconda is a Python distribution that comes bundled with essential data science libraries and tools. Jupyter Notebook is an interactive web-based environment for data analysis. So Anaconda simplifies package management and provides a convenient environment for data professionals. And of course, Jupyter Notebook facilitates code sharing, documentation, and visualization. VSC, Visual Studio Code, is a popular, lightweight, and open source code editor that also supports Python to external extensions. So it offers a highly customizable environment, supports various programming languages, and has robust extension marketplace as well. So IDEs like Google Colab, Anaconda with Jupyter Notebook, Visual Studio Code, right? All these streamline our workflow and enhance productivity in our data wrangling projects. I will give you a demo on how to install and use all these in the next video. With this, we are done. Thank you. Hello, learners. Let us download and install the required integrated development environment, that is IDEs, that are essential for the course. For the entire course, we are going to code in Hello, learners. I welcome you all to the data wrangling course. I'm Archana. I'm a corporate trainer in the data science field. Let's have an introduction to data wrangling in this module. Let's start off by understanding what is data wrangling and explore its use cases. Let's get started. What is data wrangling? Data wrangling, also known as data munging or data preparation, is the process of cleaning, transforming, and organizing raw data into a structured and usable format for analysis. It involves various operations such as handling missing values, dealing with outliers, reshaping data, and much more. In a sense, data wrangling is the critical first step in data analysis pipeline. Let's now explore the 6 steps involved in the data wrangling process. Step 1, data discovery. So the objective of this data discovery is to understand the data sources and identify what data is available. In this initial step, data analysts explore available data sources, access data quality, and identify potential challenges. It also involves defining the scope of data wrangling project and setting goals for data preparation. So what do we do in this data discovery step is we explore the dataset structure, size, and metadata, identify the data sources and gather relevant documentation, and finally gain insights into data distribution, potential issues, and initial questions. Step 2, data structuring. The objective of data structuring is to organize and format the data for analysis. So data is structured into suitable format such as tables or data frames to make it ready for the analysis. So common tasks include handling missing values, dealing with data types, and creating relevant data structures. What do we do here is we create a clear structure using pandas data frames, that is one of the libraries available in Python, or any similar structures. Define meaningful column names and index values. Handle data types and ensure consistency. The third step is data cleaning. So the objective of data cleaning is to improve data quality by identifying and rectifying errors and inconsistencies in the data. Data cleaning involves handling missing data, correcting data entry errors, and addressing the outliers. So this goal is to ensure data accuracy, reliability for subsequent analysis. So what do we do here? This we address missing values through imputation or removal, detect and handle duplicates, correct inaccuracies, outliers, and anomalies. So all these we will be doing it practically in this course. The fourth step is data enriching. And here we enrich the data set with valuable and additional relevant information. Data enrichment may involve combining data from multiple sources, adding calculated columns, or merging data sets. So this aims to provide a more comprehensive view of the data and make it more valuable for the analysis. What do we do here is we merge or join data from multiple sources, create derived features or calculations, add context through external data such as geospatial or demographic information. So we will be adding extra informations additionally, whichever is helpful for our analysis. Step 5 is data validating. And here the objective is to ensure data quality, accuracy, and integrity. Data validation checks the consistency and integrity of the data set. So data analyst or data scientist confirm that the data adheres to predefined rules and standards, ensuring reliable results. We need to verify the data against predefined business rules or constraints over here. We check for internal consistency within the data set itself, and finally validate it against external benchmarks or sources. Now the last step in data wrangling is data publishing. The objective of this step is to prepare the finalized data set for sharing or analysis. So in the final step, the cleaned and validated data is published or shared with the stakeholders. This may involve exporting data to database, creating reports, or making it available for further analysis. So what actions we take here is we document data transformations, sources, and cleaning steps as well. We export the data to desired formats, let's say CSV, Excel, or database itself, and publish it to the data repositories. So here we establish the data access controls and permissions as well. These 6 steps form the backbone for effective data wrangling, allowing us to transform raw data into a clean, reliable, and usable form, thereby making it a valuable asset for analysis and also critically important factor, which is decision making. Each and every step that you see over here out of the 6 steps plays a crucial role in ensuring data quality and usability, and the insights drawn from the data are accurate and valuable. Now let's explore the importance of data wrangling in data analysis. Data quality, data consistency, data integration, and efficient analysis. So data wrangling is actually not a one-size-fits-all process. It involves a series of steps and techniques tailored to a specific data and analysis goals. Data wrangling is of paramount importance in data analysis process for several reasons. Let's look at some of the reasons one by one. First of all, data collected from various sources may contain some errors, or it may be so unclean. There might be inconsistencies, missing values, and all that. So data wrangling helps identify and rectify these issues, ensuring that the data used for the analysis is very accurate and reliable. Raw data is often unstructured and unsuitable for analysis. So, data wrangling transforms the raw data into a structured format that can be readily analyzed using statistical and machine learning techniques. Data wrangling allows us to explore and discover insights more effectively. By preparing the data appropriately, it becomes easier to uncover trends, patterns, and any kind of relationships within the data. In the business context, data-driven decision-making is extremely crucial. Data wrangling ensures that the decision makers have access to clean and well-organized data, which can lead to more informed and effective decisions. Without data wrangling, the data analysis process can be a little time consuming, yeah, and of course, it could be error prone as well, which is definitely not desirable. So, properly prepared data streamlines the analysis, saving time and reducing the likelihood of errors. In summary, data wrangling is the foundational step in the data analysis journey. It ensures data quality, enables analysis, it facilitates insights, and of course supports decision making. Thereby, it enhances the efficiency and ultimately leads to more meaningful and actionable results. Let's explore the programming language and IDEs to be used in the data wrangling course. Python is indeed the most preferred language for data wrangling. So, especially because of its versatility and its extensive supports of external libraries. It is indeed a versatile programming language that can handle a wide variety of data formats, making it more suitable for diverse data sources. So, it also boosts an extensive ecosystem of libraries like Pandas, NumPy, Matplotlib, Seaborn, being these essential tools for data wrangling and analysis. Python and its libraries are actually open source, so thereby making it accessible and cost effective for organizations of all sizes. Python seamlessly integrates with other data science and machine learning libraries as well, like scikit-learn, TensorFlow, PyTorch, right? Thereby allowing for end-to-end data analysis pipelines. Now let's see what are the preferred integrated development environments, also known as IDEs, that are preferred for the data science course. So over here, the IDE is a software application that provides a comprehensive and integrated set of tools for software development. IDEs are designed to streamline the entire software development process, right from writing and debugging code to building, testing, deploying applications, everything in one single go. First, Google Colab. Google Colab is a cloud-based platform from Google that provides free access to GPU resources and pre-installed data science libraries as well, which includes Pandas. That Pandas would be the most widely used for in our course. It also allows for collaborative data analysis, provides cloud-based resources for computationality, intensive tasks, and supports integration of Google Drive as well. Anaconda. So Anaconda is a Python distribution that comes bundled with essential data science libraries and tools. Jupyter Notebook is an interactive web-based environment for data analysis. So Anaconda simplifies package management and provides a convenient environment for data professionals. And of course, Jupyter Notebook facilitates code sharing, documentation, and visualization. VSC, Visual Studio Code, is a popular, lightweight, and open source code editor that also supports Python to external extensions. So it offers a highly customizable environment, supports various programming languages, and has robust extension marketplace as well. So IDEs like Google Colab, Anaconda with Jupyter Notebook, Visual Studio Code, right? All these streamline our workflow and enhance productivity in our data wrangling projects. I will give you a demo on how to install and use all these in the next video. With this, we are done. Thank you. Hello learners. Let us download and install the required integrated development environment, that is IDEs, that are essential for the course. For the entire course, we are going to code in Python programming language. So the first and foremost thing that we have to do is we have to download Python. So let's search for Python. So here you could see the first link, right? python.org. And here you can see downloads. Okay, let's click on downloads. So once you click on downloads, so you could see there are multiple options here. So download Python 3.11.5. So some versions are being suggested. And when you come down, you could also see the previous versions as well. There are certain previous versions that you could just click on the download button to download the same, right? So let me go with this one that is being suggested. So click on the download button. As you can see, this wouldn't take much time at all. The download is actually complete. You can see it's only 24 MB. Okay, click over here. So now you can see some options are getting popped up. So it is asking you to install, or you could choose customized installation. I would always prefer this default option. And one very, very important thing that it's better you choose is add Python to path. This particular option that you are able to see here. Okay, so if you choose this path would be added to the environment variables so that you could locate this Python anywhere without having to go inside the installation folder. So I would always suggest this option. So click this add python.exe to Python. Then install now. So it could ask for permissions. Make sure you give yes. This would take only very few minutes. So Python is the extensively used language for the entire data science domain. So this is the most sought out language as well. So installing this would be really helping us to explore the language, right? So this comes pre-installed with certain, like say, whatever is already been defined, some functions, modules, packages, okay? Everything will gets installed with while you install the Python. Okay, it's done. So then you could just click on the close, right? Disabling path length limit, that's not required. You could just click on the close button. Okay, now how do I verify that Python has got successfully installed? You could just go to the command prompt. I'm opening command prompt. And over here, you could type Python --version. So this would give you the version of Python. And you could type where Python. So this would tell you the location where your Python got installed, right? So this is the first one that you're getting here. That is app data local programs Python 3.11. Okay, this is the place where your Python got installed. So this is how you could verify. And of course, you could search for Python. So you get Python IDLE, which is an integrated development learning environment. And then we have Python as a REPL. So there you can code something and directly check the output. So I'll open Python REPL now. Just search for Python. So you should be able to open this. So over here, always the first thing that we do is we would like to have printed hello world as an output. So we have a function called as print. This is a built-in function that comes in Python that would print anything. As the name suggests, it's quite intuitive. And let's say I want to print hello world. Yeah. And you have to print this within quotation marks. Now this would print me hello. So this is how you can check whether your Python app installed successfully and whether if you are able to use print command, it is able to print your output correctly. And you could do some mathematical operations as well. For example, if I write 2 plus 3, 5. We get 5 over here. All right. We need to install certain modules and libraries as a part of our course. Explanation of these modules that I'm going to install will be covered during the course itself. Let us first install the most widely used library, which is NumPy. So for installing this, we need to use pip followed by install and then NumPy. Pip install NumPy. So when you do this, you can see that it would start installing NumPy. NumPy is extensively used for numerical operations, as in fact NumPy itself means numerical Python. NUM stands for numerical and PY stands for Python. Next, let's install pandas. Pip install pandas. So pandas would help us in data manipulation, data analysis, data wrangling. Complete end-to-end analysis of data can be easily done with the help of pandas. Pandas is an amazing library exclusively used for data analysis. It is getting installed. And for data visualization, let's install matplotlib. Okay, so I've written here pip install matplotlib. This would help us draw graphs, multiple types of graphs like bar graph, scatter plot, histograms, pie charts, box plots, and many different types of graphs. We do have one more library called as Seaborn. So let's install that. Pip install Seaborn. So Seaborn is yet another data visualization library. This is more easier to code when compared to matplotlib. But yeah, both has its own advantages. We could use pip list to list out all the libraries that is being installed. So you can see that apart from the ones that we install, there are already some set of library that was coming pre-installed with Python itself. So you could just have the list of all the libraries that has been installed over here. Let us first install Visual Studio Code. First of all you need to just search for Visual Studio Code. And you can see the first option, Visual Studio Code, Code Editing Redefined. Just click over there. And here you can see the download option for Windows. If you just click on the down arrow, you could see the other OS as well. So whichever is your operating system, you may download this thing. Since mine is Windows, I'm going to download for Windows. So as you can see, it is getting downloaded. It is done, right? So now I'm going to click over here. Okay, so here you can go through the terms and conditions. It is from the Microsoft only, so it is 100% trustworthy, right? So it is Microsoft Visual Studio. So you can just go through the terms and conditions and then agree. I accept. Next, preferably it's good that we choose the original folder itself, but if not, the default one, usually it will be from C. You could change this as well. Your choice, but I would leave it to the default location. Next, you can see the name, right? So let it be the default option. And here you can enforce to not create a shortcut in start menu folder, but I would like to create it. So I am not enabling this option, right? Next, you can see you can choose those options. It's very, very useful. You can choose create a desktop icon and add open with code, right? And add open with code to action, like any respective file that or folder that you could entirely open with Visual Studio Code or a particular file that you want to open. All this you can find this option from the right click itself. So I find it very useful. So I am checking all these. And now it's time to click on the install button to install. It's installing. It would take only very few minutes or more time. And after it's completed, you can click on launch Visual Studio Code button. Okay, so I choose this option and I click on finish. So as you can see, this is how the home page of Visual Studio Code would look like. By default, the theme is dark theme, which is good for our eyes, right? So here's how the Visual Studio Code would look like. On the left, you have Explorer, and in the Explorer, if you have opened any folder, you would be able to open the particular folder here or explore. And here you can use the search option, and here you have source control and run and debug option, and then you have extensions. So in the extensions over here, right, we could install like few things that would be really useful for us, like say Python and Jupyter Notebook, right? So whichever is useful, we could install over here. Let us install Python in Visual Studio. Make sure you have clicked on the extensions, right? On the left side, this is where you locate the extensions. After you click on the extensions, you can search for Python. And here you are getting multiple search results. You could choose the one that is available from Microsoft itself. This is a verified one, and click on the install button. So this would enable you to code in Python, and it would print the Python code output directly in the Visual Studio Code itself. So I'm installing the Python application. So this would support and this would actually interpret your Python language. The extension is installing. Okay. So now with this, we can create .py files that stands for Python as shown over here, and we could run our output. Okay. So there is also called as code runner. So you can see this would help us run the code efficiently. So I would recommend it installing this as well, and it has been installed. Coming back to the Explorer, here you can see open folder icon. So when we click on the open folder icon, so it would help us locate a folder in our system. And after locating a folder, we would be able to open that particular folder. So here we will be always working in folders. So I have already opened a folder called as VSC demo. So the first time when you open, and you can see I've stored it in the documents folder. Okay, it will ask you whether you trust this folder. You could give yes, and then you trust the folder. So once you click on that open folder button, now this is exactly how a folder would be getting opened for you. Huh? And this is how it would look. This is how a Visual Studio Code would look, right? Let's create a new file by clicking on this button over here or right click new file. Okay. This time I would write a Python script. So let's say I write like Python script .py. .py is the extension for writing a Python. And over here, I would like to write the same command, which is print, okay, parenthesis, and then within quotation marks, you write what you want to print. See, Visual Studio Code is amazing that it has some autocorrect features. It will suggest you all the codes that you would or like to write, and it also gives you the documentation. And press Ctrl S to save your file, or you can click on File and then save. Now, on the top right, you could see this play button over here. This is where we can run our code to check the output, right? So when you click on the drop down menu, here you can see Run Python. Because I downloaded Code Runner, I was able to get this option. And now you could see that it is going inside the folder, Documents, and then VSC Demo, the folder that I opened, and it is indeed printing me Hello World. So this is how you could use Visual Studio Code to code in multiple languages and install the respective extensions to efficiently use and code. Let us install Anaconda now. It is a very useful platform that would help us launch Jupyter Notebook to code in Python effectively. So just search here Anaconda install. So you can see the first link, which is free Anaconda. This is from anaconda.com. So you could just open over here. And here you can see when you just come down, here you can see the download option for Windows, right? So additionally, you could choose any other operating system based on which operating system you have. Here you can see Windows, here you can see Mac OS and Linux as well, right? So I would download this for Windows. So the downloading is going on. It would just take few seconds, and with that, we would be able to open Anaconda Navigator. So two things gets installed with Anaconda. One is Anaconda Prompt and one other is Anaconda Navigator. Anaconda Prompt is just like command prompt where we can write command line codes over there. And Anaconda Navigator is the interface wherein we can launch multiple IDEs over there. So the one that we would be using in our course is Jupyter Notebook. So this is where with the help of Jupyter Notebook, we would be able to create an interactive environment. Okay, it is done. So I'm opening it. So you can see Anaconda setup has opened. You can click on next and you can go through the agreement over here. So this is a very safe one. You can read all the agreements and then I can click on I agree. And you could choose if you have multiple users installed, then you could choose for all users, or it's just, I think it's better I choose all users. It asks for permissions. Make sure you give all the required permissions. And here you can see the location in which you need to install your Anaconda. So by default, it will be C program. So I would keep it the default location itself. And here you can see create short menu and register Anaconda with the version for Python 3.11, right? So click on install. So this also installs along with this Python version 3.11 as shown in the previous page. So whichever is the latest version at the time of downloading, the particular Python version will be downloaded. So those who already have Python, no problem. You can continue to, there is no need for you to uninstall any previous versions or anything like that. You could just continue installing Anaconda itself, right? And for those who haven't installed Python yet so far, no problem. You could just directly install Anaconda and this would install along with the Python. And one advantage of using Anaconda is that we have most of the libraries comes pre-installed. I mean, most of the widely used libraries that we would be required in the data science course overall, all those libraries or modules would be coming pre-installed with Anaconda. So it is a very useful tool for us. And Jupyter Notebook enables you the way wherein you can code and you can write use a markdown as well, where you can mention or write, add images, add headings, add text. You could write anything. You can have a description, a good description of what code you are writing and what is the purpose of you writing the code and what analysis that you have made from your code, right? So all those things you could mention in the markdown along with your code. So that is why Jupyter Notebook is also very, very useful. It is installing. This would just take few minutes. So it is downloading and extracting all the packages. Many useful packages and modules would get installed along with this.
Just a few more minutes. Almost done. After a few minutes, it is done. Let's click on next. Next. And I'm going to launch Anaconda Navigator. right? So Anaconda Navigator is the one where you can find the interactive IDEs. So let me click on Launch Anaconda Navigator and finish. So you can see Anaconda Navigator is getting launched. On the center, you can see a green circle. So this is what verifies, indicates the Anaconda is actually launching. It initializing. It will take few minutes. And it is launched. So you can see here, this is how Anaconda Navigator would look like. And here you can see there are multiple IDEs. You can see over here, and Jupyter Notebook is one such. You can also see Visual Studio Code, VS Code, RStudio, Oracle, like so many IDEs are there. So I'm going to launch, and yeah, Spider is also a famous one. And we are going to use this Jupyter Notebook. So here you can see launch button over there. So click on the launch button. It will automatically launch in a Google default browser, right? In my case, Google Chrome is my default browser, and I would like to launch my Jupyter Notebook in Google Chrome only. Okay, I click on OK, and here we go. So this is how I install Anaconda, and this is how I can launch Jupyter Notebook. And from here, we can open any folder and start creating our IPY files, which is in Python programming language. I have opened the documents folder now. So from here, you could see this option called as new on the right side, right? So this, with the help of this new, you could actually create a new IPY file, right? This is called as Python. You could see that Python 3 IPY kernel is mentioned. So once you click over there, you will be redirected to Python work, right? And this is Jupyter. This is from Jupyter. So you can see that this file called as untitled.ipynb is being created. Now we saw that the default extension of Python is .py, and here it shows ipynb. So this means that this is Python node. So over here, I could write a code, then I could write some context as well. So I can convert this code to markup, right? That is why the name node. So now if I convert this to markup, I could write something like, say, my first Python code, right? Or my Python code. And you could click on the run button, or you could press shift and enter. And now this cell is a code cell. And over here, we could write print. Print is a function. And then we would like to print hello world. So let's write hello world. Now, either you could press on the run button, or you could press shift and enter. This would print the hello world file. So we could also do any operations, like say for example, 10 plus 5. And if I press shift and enter, you could see I'm getting 50. And you could click on this untitled to change the name of the file. So let's say I change the name as Python demo. And as soon as I change here, you could see that inside your documents folder as well, it is being saved as python demo.ipyn. So this you are trying to code locally, and all the codes that you are doing is being locally saved. Now, let's try to open Google. And over here, let me try to find Google Colab. And you can see that welcome to collaboratory option is there. And here you can see Google Colab. So Google Colab hosts the same Jupyter Notebook kind of interface, and this will work online. So now when I click on this Google Colab, you can see that it would open an interface. This is from Google itself, and this hosts a Jupyter Notebook service. And what it requires is this: we just need to log into our Google account. Now, when I click on this new notebook, it says sign in required. So let me sign in. I'll just first sign in. So I have signed in. Now, this is how the Google Colab interface looks. As you can see, this is very much similar to Jupyter Notebook. Over here, you can see add code and then add text. Add text is just like your markup, right? This was our markup. So markdown, you can add any comment or text over there. You can add images as well. Markdown is a language actually, where you can also have headings, and you could write anything. You could add images, any links, hyperlinks, anything could be written in markdown. So, and here we write our Python the same way. Over here, first of all, I told you this is an online server connected to our Google account. So first of all, we need to connect. And here you can see untitled.ipynb. You could change the name to anything that you decide. So let's say python core.ipynb. You can see that it is going to give us its own RAM, right? You can see that we have got some 0.74 GB RAM and some disk space as well. So we are getting this from Colab itself. That's amazing, right? Now over here, you could write your Python code, print hello world, and you can see the run button on the left side itself. Either you can click on the run button, or again you can press on shift and enter. So when you press shift and enter, it runs and goes to the next. If you press control enter, it would just run. So now let's say I add a text, and you can see that double click to enter or edit, right? And then here, let's say I had a heading. So you could add a heading by just putting this hash symbol followed by whatever you want to write over here, right? And press shift and enter. You can see that you have created a heading for yourself. And over here, I am writing my first code, which is hello. So these are the different interfaces that you could use in code in Python. Thank you.
Hello, learners. Now that we are done with the installation of Python and all the required IDEs, let's get started with Pandas library. Pandas is a very extensively used library for data wrangling. Pandas is a highly versatile Python library designed to facilitate data manipulation, analysis, and preparation. It has gained immense popularity in the field of data science and data analysis due to its rich functionality and ease of use. Pandas is an indispensable tool for data wrangling due to its versatility, efficiency, and extensive functionality. It simplifies the process of preparing and cleaning data, allowing us to focus on deriving valuable insights from the datasets with ease. Pandas is an open source library which is primarily written in Python programming language, and some parts of it are also implemented in lower level programming languages like C and Python. So, according to the official pandas documentation, the vision of this pandas libraries are to be accessible to everyone, free for users to use and modify, being flexible, being powerful, easy to use, and of course, fast. Pandas is built on top of two key libraries named NumPy and Matplotlib. NumPy, in short for numerical Python, is a fundamental library for numerical and scientific computation in Python. So, Pandas relies heavily on NumPy arrays to store and manipulate the data efficiently. NumPy provides the foundation for many of the data structures and operations that are used in Pandas. Matplotlib, though while it is not a strict dependency, Pandas can work seamlessly with Matplotlib as well, which is a very popular Python library for creating data visualizations. Matplotlib can be used to plot and visualize data that are stored in Pandas dataset. In a sense, Pandas leverages the capabilities of NumPy for efficient data storage and manipulation by using the NumPy arrays, and it provides a high-level tabular data structure, that is data frames, that simplifies data analysis tasks, that makes it easier for data scientists and analysts to work with structured data in Python. Now, let us see how do we install Pandas. So, to get started with Pandas, we first need to install it by using a package manager like pip or conda. So, we could use pip install Pandas, or if we are using Anaconda, then in Anaconda prompt, we could also use conda install Pandas. Once installed, the next step is to import it. One can import Pandas into the Python environment, any IDEs, using the import statement, import Pandas as PD. Here, this convention using PD as an alias for Pandas is the most commonly used in the Pandas community. Let's now discuss about the features of Pandas. Certainly, Pandas is very much essential for data wrangling due to its versatility, the powerful capabilities and all that. Now, let us see some key points that actually highlights why Pandas is essential for data wrangling. Data structure. Pandas provides easy-to-use data structures, particularly data frames, which are well suited for tabular data. Data frames allows us to organize and manipulate data efficiently, making it a natural choice for data wrangling tasks. Data cleaning. It offers numerous functions for data cleaning, including handling missing data, that is NaN values commonly called as, removing duplicates, and converting data types, all of which are common tasks in data wrangling. Data transformation. Pandas enables us to perform a wide range of data transformations, such as filtering rows, applying functions to columns, pivoting, melting, reshaping data, etc., etc. So all these steps are very much essential for preparing data for analysis. Data selection. One can easily select specific columns or rows based on Boolean conditions, labels, or positions, index positions, labels, or in any which ways using pandas, any of these. So this makes it pandas a straightforward way to extract relevant portions of the data during the wrangling process. Data merging and joining. Pandas provides powerful tools for merging and joining multiple datasets, which is very crucial when we need to combine data from multiple sources or we want to perform some complex joins. Combining data from multiple sources is very much essential. Data aggregation. Aggregating data is a common task in data wrangling process, and pandas offers functions for grouping data and performing operations like sum, mean, count on the grouped data. Time series data handling. So, for time series data, pandas has specialized tools and functions for resampling, time-based indexing, and handling date and time data efficiently. External data sources. We can use pandas to integrate with external data sources. Of course, pandas can read data from various other sources, including some most commonly used files like CSV, Excel, JSON, and also databases like SQL database and web APIs as well. So, all these make it convenient for working with data from different origins. Custom functionality. One can create custom functions and apply them to the data using pandas. So this flexibility allows anyone to implement domain-specific data wrangling logic as and when needed. Efficiency. Pandas is highly optimized for performance, make it efficient even when working with large data sets. It employs vectorized operations, which can significantly speed up the data manipulation tasks. Rich ecosystem. Pandas is a part of the Python ecosystem, which means one can easily integrate it with other libraries and tools that are commonly used in data analysis and machine learning process, such as NumPy, Matplotlib, scikit-learn, and much more. Community and documentation. Pandas has a large and active user community, which means one can easily find extensive documentation, tutorials, and community support to help one and all learn and troubleshoot any issues. Now let's discuss about pandas data structures. Primarily, there are two main data structures, which is series and data frame. Let us look at what is series. Pandas series is a one-dimensional labeled array that can hold data of any type, like example integers, strings, or even custom objects. You may think of a series as a single column of a data in a spreadsheet, or a labeled array, or a single variable in statistics. Pandas series are homogeneous, meaning it can contain data of only the same type. We can have any data type, for example, integers, strings, objects, but all the elements of the array should be of the same type. We cannot have a combination of different types like some integers and some strings. So, each element in Pandas series are associated with a unique label called index. This index allows for efficient and labeled access to the data. We can access this data by using its index position, which is zero based. Index starts from 0. This is generated by default. Or we can also access the data by using the label as well, which can be string of any hashable object. Here you can see practically how our pandas series would look like. Here the index position starting from 0, 1, 2, and 3 on the left side. 25, 50, 75, 100 are the values that we have given. So these belongs to the integer type. You can see the D type, which is data type as integer. So we have here index, the elements, values, and the data types as well. Next, let us explore pandas data frame. Pandas data frame is a two-dimensional size mutable and heterogeneous tabular data structure with labeled axes, that is rows and columns. It is very similar to a spreadsheet or a SQL table where we deal with completely a table of rows and columns. Here, each column in Pandas data frame is actually Pandas series because each column is one dimension. That is why. Overall, Pandas data frame is two dimensional. Unlike Pandas series, data frame is heterogeneous, meaning it can contain data of different types, provided in one single column contain the same type, right? Whereas it can have a different data types in different columns. Here, size is mutable, right? We have row and column labels over here. Data frames can have both row and column labels. So this makes it easy for us to access any specific data points. Rows are indexed with unique labels and columns are actually labeled. This means one can access data using labels, making data manipulation and data analysis more intuitive and efficient. So now that the size is also mutable, one can dynamically add or remove elements from a data frame or series as well. Size is mutable for both. This flexibility allows us to modify data within the series or our data frame as our data processing needs changes. For example, we can add new data points or drop unnecessary ones, making Pandas data frame and series a versatile data structures for various data manipulation tasks. You can see a sample of data frame over here. Like I said, here it's made up of rows and columns. In the columns, we have sepal length, sepal width, petal width, class. This is a famous iris data set. And we have around 150 rows as mentioned over here. Each and every column is separately referred to as a Pandas series. We will have a practical demo on creating Pandas series and data frames in multiple ways, accessing data, slicing, indexing, manipulating or updating the data, and deleting the data as well. So I'm going to start in Google Colab IDE. This is Google Colab. Here, most of the libraries that we will be essentially using in our data analysis and data wrangling comes pre-installed over here, right? So even if we try to install over here, since we will be writing the pip install pandas, which is actually a command line prompt, if we want to write the same over here, we need to start with the exclamation mark followed by pip install pandas. If we are writing here, installing directly from the IDE itself, this is a command line prompt, so we have to start with the exclamation mark. Otherwise, if you're directly installing, then you don't need to use that. Either you can click on the run button or you can press shift and enter. You can see that it says requirement already satisfied. Like I said, most of these libraries comes pre-installed. Pandas is also pre-installed in Google Colab. Next, let's import. Import pandas as PD, right? This is what most commonly used alias name that we give for pandas as PD. Again, let me run this. With the help of div, let's try to access all the methods and attributes that are associated with pandas. Okay, so you can see that we can use so many methods and attributes, but our main target is data frame and series, right? So let's start creating series and data frame. Okay. Hello, learners. In the previous video, I discussed about installation of pandas. So I will add a markdown over here. Then we discussed about importing pandas. Remember that it is necessary to import pandas only once, right? No need to import again and again. Only once if it's imported, we can use pandas throughout this particular code. And we saw the different attributes and methods associated with pandas. So we also saw that there are two different data structures that are associated with pandas, which are series and data frames, right? So we saw that series is a one-dimensional homogeneous array and mutable size. Homogeneous as in all the data types should be same, or should be of integers, float, or multiple types, but it should be same. And data frames are two-dimensional. Here also the size is mutable and it has tabular structures with rows and columns. Potentially heterogeneous as in each and every column should be of same type, but different columns can be of different data types. So we saw that these were the two things regarding series and data frames. Let's get started with Panda series now. So when it comes to Panda series, here we have few parameters that it takes: data, index, D type, name, and then copy. So how do we create a Panda series? By calling our pandas module. In this case, we have given alias name as PD and dot series S in capital. Remember that Python is case sensitive. So capital S and small s are different, or lowercase and uppercase. So here strictly S should be of an uppercase letter followed by ERIES. So this is exactly how we should declare. And then comes these parameters. Let's discuss about this one by one. First of all, what kind of data we can give for creating a Panda series? So here we can give like generic data structures that we have in Python, like lists, tuples, sets, dictionaries, constants, and we could also give NumPy array as well. NumPy is yet another powerful module, numerical Python module. Then we have index. So index values must be unique and hashable. If index is not given, by default, it would take the range index that starts from 0. So the index will be automatically given from 0 to the length of data minus 1. If we want to give our own index, that optional also we can give with the help of this index parameter. Then we have D type. D type stands for data type. If we are not specifying any data type, implicitly it will infer from the data itself. So Python is very high level programming language that it understands what type of data we are giving for the creating the series, and the data type will automatically be inferred. But if we want to give or modify it or change it according to our own data type, force it to modify, then we can use this parameter. Then we have copy. So copy is where we try to use this to copy the input data and the default value is false. So these parameters are enough for us and most commonly used ones that are being we created for creating a series. So let's start with create an empty series, right? So pandas is already imported. So I'm simply just going to start using this. Let me store it in a variable called as series. So series equal to pd dot capital S4 for 51. So the length of this data is actually 5. But since the index version starts from 0, it goes from 0 to 4. Right? So now let me create a string list. String list equal to, let's say, I just write A, B, C, and then D. And I'll create a series out of this. Directly, this time I'm not going to store it in a variable. Like I said, since data is positional, it's belong in the first position. We don't need to mention data equal to. We can also directly pass on the list or whatever series, the sequence data type we are trying to give over here. Now I will run this. So here you can see that this particular data type is object. Now, in the previous case, Python automatically inferred that this particular series, the list is containing all integers. So it was assigning the integer data type. Here, everything is a string. Then why did we get object here? Because in pandas, we have int, float, and object. Bool also we have. Only these we have. Now, why object? Why not string? Object is very much better because it takes arbitrary length. Object can be taking mixture of different data types as well, but when you project having multiple data types into one single list, and when you try to create a series out of it, you will be getting object only. So two advantages. One is mixed data types here can be given as object. Even all string will also be given as object. And one more advantage, when compared to string, this particular pandas has object type which is actually having arbitrary length. So this way object stands better. Now, if you want to forcefully change the index to start from 1 to 5, because here you can see that, sorry, 1 to 4, because we have 4 elements over here. So if you want to forcefully change it, you can pass on the index parameter. So I would write here index equal to, I'm mentioning here index because, right? So here you can see we have index parameter as well. So it is optional. All these are optional as you can see, right? So whichever you want to change, that we have to give. So now let it take from my range. Okay, I am using range function over here. So I want to create, as you know, it has start parameter and then stop parameter, and optionally we have step parameter as well. So in case if I say start at 1 and then stop at 5, remember that stop will not be included. So it will stop exactly at 5. So we get 1, 2, 3 and then 4. Here you can see that now we have changed the index position to actually make it start from 1. So this way you can do. Or if you don't want to give 5 here directly, if you want to make it explicitly calculate, you could also give length of string list plus 1, right? So that way also you can give, because here length would be 4. So you can give length plus 1. So that will turn 4. Next, we will see how do we create a series using range. So now you all know, you're all aware of how do we work with range. So using the range function, let's say I want numbers from 10 to 15. So I have to mention here 10, 16, right? So when I write 10, 16, then I would be getting my numbers from 10 to 15 because 16 will not be included. Then we have series equal to pd dot uppercase s, remaining things in lowercase, and then I will pass on the data. Then let's print the series. So here you can see by default the index position starts from 0, and right from 10 to 15 index positions are automatically being allocated. And you can also see that the data type stands as integer. It by default it inferred directly the data type from the given series itself. Next, let's see how do we create a series from NumPy array. NumPy is a very useful library. In fact, we discussed that pandas is also being built on NumPy only. So let's see if we have a NumPy array, how do we create a series from NumPy array? So for that, I have to import the NumPy module. So import NumPy as NP, and let me create a data using NumPy array only. So NP dot array. So let's say I create a string array. So I write here A, B, C, D, and then here I write E. Series equal to PD dot uppercase S series, and then let's pass the data. Okay, and let's print the series as well. So this is what we get. It's perfectly working like just any other case. As you can see, in whichever way we create the series, the end result is what we get. This is how exactly our series would look like. So if we want to forcefully change the index like I discussed, here you can give index equal to range of, let's say I want the index position to start from 1. So here you could write 1 comma len of data plus 1. Make sure that the numbers you give in index, I mean the length of the index and the length of the data should match. So why did I write here len of data plus 1 is because the length I have over here is 5. So you know that I have to start the range from 1 comma 6. So here I go in len of data plus 1. So the advantage of using this is if I want to update my data, I can just don't need to update the stock number. I can just make it simply work once we try to program it. Let it calculate the index as its own. Right? So now, next part. Create series from dictionary. Again, from Python dictionary, let's see how do we create a panda series. And one more thing, remember that dictionary keys, remember that in dictionary we have key value pairs, key colon values. So here the keys of the dictionary are used to construct the index of panda series, right? Because dictionary keys are immutable, hashable types, and only like strict like string, integer, tuples are only allowed for dictionary keys. So over here, by default, dictionary keys will be used to construct the index. So let's see that. So let's say I create a dictionary this time, open and close curly brackets, and then in goes the key values. So A is my key, 1 is my value, and then B is my key, colon 2. So key, colon, value, key 1, comma, value 1, comma, key 2, comma, value 2, and so on. Next, I have the third key, which is C, and the value is 3. Now, if I try to create the data, you can see that automatically A, B, C are taken for index positions and 1, 2, 3 are taken as values. And one more thing, always remember that the data type here will always tell you the data type of the values, the elements of the panda series and not the index. Even in previous cases, you would have observed that here my like my type, the values that I give, the elements of my series are A, B, C, D, E, right, which are string. So hence I get the data type of object. So we would never get the data type of index over here. If we want, we can explicitly find, but the D type that you find from here when you try to print the panda series, that always belongs to the elements of the series and not the index. So hence you get int 1, 2, 3. Since we have 1, 2, 3 here, we have int 64. Now let's do few changes over here. Now let me take the same dictionary. Okay, I've taken the same dictionary and this time again I pass on the same data Okay, and I'll try to change the index. Now, in this case, let's see what happens. In the previous cases, you clearly saw that I was casually being able to change the index according to my wish. But in this case, I have a dictionary with me, and the index are automatically being constructed from the dictionary keys. But if I try to explicitly give some index, let's see what happens. You'll find it interesting. So as you can see here, I'm deliberately changing some orders. I've written here, but the default, the index currently are A, B, C, but here I'm writing C, A, and then X. I'm writing X is not even there in my dictionary. And then I write here B. So in this case, here you go. Here you can see that in place of C, my C value is actually 3. As you can see, the key of C is 3. The index, what it's doing, it's trying to retrieve the particular value in the given order of index. If we don't pass this, we saw that the order is by default coming with the dictionary. The first key value, the second, third, and so on. Though dictionary is not ordered, dictionary is unordered, still we are able to give in the way that we passed. But if we try to a parameter, and I'm going to give argument as X, Y, Z. Now let's see what happens. Here you can see that since I have 3 index questions over here, but my data is only 5, which is just a scalar, which is a one single number constant. Here you can see that we have 3 elements because I have 3 index, and for all the 3 index, the value is given as 5. So when you want to create a series that takes a same number for all throughout your series for different indexes, you could use this approach. Yeah. And we could also use numerical indexing for the same case. Let's say I write here 6. And then here I use index equal to range of 1, 5. So here you can see that I've got 1, 2, 3, 4, and all the elements takes the values of 6. Either way, you could use this, right? Now we are done with how do we create the panda series in multiple ways. So we first saw how do we create a series using list, range, numpy array, dictionary, and from scalar as well. Now it's time to explore how do we access our panda series. Accessing data from series. Okay. So I'm going to create one more panda series now, and I would store it in a variable so that we will see how do we access, we use indexing, slicing kind of thing. How do we access data from series? pd.series. I simply want to create, let's say, a very basic list of numbers. And index, I would give a label index over here. So this we call as a label index, right? So label index as in when we pass, like since I have 5 elements, I will give 5 index. Okay, so like since I'm giving a string thing as a label and I'm not using the default 0 to 1. Okay, so this is called as label index. Though we are giving label index, the default indexing of 0 to len of data minus 1 still exists. I'll prove you that. So here you can see that I have 1, 2, 3, 4, 5 as my elements, and index goes from A to E, and of course the data type belongs to the data type of the elements only, what elements I have. Now we will start with retrieving data using index position. When I say index position starts from 0, like how we have been looking at the previous cases. By default, the index position starts from 0 only, right? Like we saw over here, right? Though I have changed my index, this is called as label indexing. Though I have given my own label for my index, still we can retrieve any element using the index position. So now let's say I want to retrieve first element using index position. So here I write series, the variable where I have stored my panda series, then square brackets, because we index using square brackets only, even for a list, for a tuple, for a dictionary, in whichever cases, the basic Python data types that we have been using, we always index with the help of square bracket. And here I'm going to get my index position. As we know, the first element index is actually 0. So here I give 0, and when I run this, okay, here you can see that the first element of my panda series is 1. Now let's say I want to retrieve last element again using index position. If I want to retrieve the last element of the series using index position, right? As you can see here, there are 5 elements. So index starts from 0 to 4. Either we can give 4 over here. So write series indexed or square brackets and then write 4. And here you get your last element, which is 5. Or you could also use negative indexing. So I would just comment this. You can use negative indexing or backward indexing. So by default, when you use a positive number, you get the number like indexing starting from 0 from top to bottom or from first element to the last element. Now, when I give -1 here, I would be eventually getting the last element, which is 5. So here the negative indexing starts from -1. -1 for 5, -2 for 4, and minus 3 for 3, -2, and then -1. So this is how, sorry, 3 and then -4, right? So this is how we can use negative indexing as well. -1, -2, -3, -4, and then -5 for the first element if we want to use. So now I can also retrieve my first element using index label as well. Here, as you can all see, I have given my labels also apart from the default indexing. Here, I have given my first element label as A. So, if I write series, square bracket, and then remember, since it is a string type, we have to write this within quotation marks, right? Now, when I run this, again, I got my first element. Now, we can also get, let's say, I want to get the index with D, right? So here I can also write series index D. So here you can see I've got the fourth element with this. Okay. Now, if we want to retrieve elements using multiple elements using labels, okay. So let me write here. Retrieve multiple elements using their labels, then what we can do, we have to pass the labels as a list. Okay. Regularly, how do we use indexing? We open and close square bracket. And inside the square bracket, if it's only one label index, I can write it directly. But since I want to pass multiple, here I have to use open and close one more square brackets because this takes a list of index positions. And over here, let's say I write A, C, and then I write E, right? And when I run this, here you can see that I have taken only A, C, and E, which is 1, 3, and then 5, right? This purple square brackets indicate the list and the yellow square brackets indicates your usual way of indexing. Remember that there are two types way in which we did indexing. One is with the help of the index position and another one was with the help of the label. right? So the label is also called as a key for the particular series. Now, imagine I write series index 7. Do I have any 7 index position over here? This goes 0, 1, 2, 3, 4. No, I have only till 4 index positions. Now, when you try to give something that's not even there in my series, when you try to access something which is out of the bound, here you are going to get index error. And you can see that index 7 is out of bounds for the access 0, which refers to all the elements with size 5. The size of the series is actually 5, but I am trying to access using index position, which is not even there. So I would just comment this off and I'm keeping it over here so that you be mindful of using the correct way of finding the index. Now the same way, imagine I give index F, label index. Now we saw that here I have the label index from A, B, C, D, E. Only that I have. And I don't have F here anywhere. Now when I try to do this, here you can see that we got key error, right? So we have got key error over here. There is no key, meaning there is no label indexing named F in our data. So hence we get key error. Again, I will comment this and I would specify the error over here. So this is how we can try to access elements from our series. Now this we saw how do we access single elements. But then if we want to do, let's say, access multiple elements using index positions, or if you want to multiple index elements that are in sequence, then we do something called as slicing. What is slicing this series, right? So slicing series. Now what happens in slicing series? So I would mention here, when you want to take more of the, when you want to retrieve or extract more index positions or more index values over here, then in that case, we use this approach of passing multiple index positions. So here, just like range, how do we have start, and step? Here also you can give start, colon, stop, colon, step, right? So this is how you can slice slice multiple elements from your series. Now let's discuss what are the default values. So what happens if you skip giving your start, or step, right? There should be some default values for certain things. By default, if you don't give what position you want to start from, by default, it will start at the first element index position, which is 0. Then if you don't give at what part you want to stop at, by default, the stop index position is the len of the series minus 1. By default, it will stop at the last element, right? Sorry. Yeah, it's just len of series because when we mention the last element, anyway, that will not get included. So it is exactly len of series only. Then we have stop, step, okay, and by default the step is 1, meaning 1 by 1 it will get incremented. If I start at if I start right index position 1, then when I say step size 1, I keep on adding 1 at every step. 1 plus 1 2, 2 plus 1 3, 3 plus 1 4, and so on. And if you change the step size to 2, then when I give start index position as 1 and I give step 2, then it would be like 1 plus 2 3, 3 plus 2 5, 5 plus 2 7, and so on. And you could also give negative values for step as well. So in this case, it would just subtract from your index positions, whatever index position you are starting at. So this thing is very important to know. And why stop is len of series? Because anyway, len of series, like it stop value will not get included. 1 minus that particular data will be included automatically. So by default, this is what it is. Now, I want to retrieve first three elements from my series. So when I say first three elements, the elements that are having index positions 0, 1, and then these are the first three elements. Now, how can we do this smartly? Series, square bracket. Again, remember we have to always use square bracket. And here I have given you the order. You could mention start, colon stop, colon step if you want to do slicing for multiple elements. Then I will mention here start at 0 because I want to have 0. I want to extract first three elements. So I have to start from 0, obviously. Then when it comes to stop, right? Remember, I want to have only 0, 1, and 2, and I want to include 2. If you write 2 over here, then as you can see here, you will be getting only the first two elements and not the first three elements because it would stop at the element at index position 2, right? So remember, give one extra for this. Stop at 3. So when I say start at 0, stop at 3, I am going to get the index position 0, 1, and 2, meaning the first three elements. And one more thing you have to remember that it's not mandatory for you to give 0 over here. Even if you don't give 0, if you just write series and leave it empty, when I say don't give, it should not be skipped and it should not write 3 here. If you write 3 here, you will be getting only the third element, right? So be mindful of these things. Like when you write only 3, it will do only indexing. It will take the third element. If you want to do slicing, then again open and close square bracket, put a colon over here. Just put a colon. There is no need for you to write 0, colon 3. Instead, you just skip this 0. If you skip writing the number for start, and then you put colon, and then you write 3. Now, when you run this, you get exactly the same result of what you got in the previous case. A, B, C, 1, 2, 3. And here also A, B, C, and 1, 2, 3. Now, the same way, if I want to extract the last three elements, with index position 2, 3, and then 4. Now, two things I can use here. One is, again, I can use series indexed. Okay, since I want to start at 2, I write here 2 colon, and then you could leave it empty. Why leave it empty? Because if you try to specify some index position over here, that particular element will not be included. So in our series, we have 5 elements, right? So we have 0, 1, 2, 3, and then 4. So if you write 4, the last element will not get included. So you can see here, when I write 4, I get only the index position 2 and then 3. I don't get the element at my fourth index position. So better if you want the last one also, then you exclude it or you can write 5 over there. Now, when I run this, you can see that here I have got the last 3 elements, 3, 4, and 5. You could also use negative indexing as well. You could also write -3 colon if this is easy for you. So -3 automatically refers to the last but third element from the last because negative indexing searches from the last. And I leave the colon, the stop indexing empty and I get exactly the same result. Now let's start using the step index. Let's say I want to reverse the order of my series. Then what I do here, series, square bracket, and this time I'm going to use step. But you can't use it right away. There is an order, start, colon, stop, colon, step. So when you want to use step, remember there are 2 colons in between. Do not forget the colons. The colon is what represents the slicing way, right? So I have to give 2 colons here because I am leaving it empty for start and I'm leaving it empty for stop because I want to start at 0 and stop at length of data, which is 5 in my case. And here I give step as -1. Why -1? Because I want to start from 0 and then I have to go in a reverse order. So you get exactly 5, 4, 3, 2, 1. Or index position E, D, C, B, A, right? Index label. Or when you speak about index position, this is 4, 3, 2, 1, 0. Because I give step as -1. Till now, I did not use step. So it was just taking the next data. So it's not that we have to always give 1 and -1. You can give any number as you wish. So you could also give, if you want alternate elements, okay, we could also give step value as 2. So colon, start I'm leaving empty, stop at I'm leaving empty. And in place of step, let's say I write 2 over here. So here you can see that we have got all the alternate elements A, C, and then A. Now let's say I want to get the elements at index position C and D, but I don't want CD, but I want DC. So I want to do both. I want to reverse also, right? I want to reverse also, and then from this I want to get only C, D, and then C, right? I don't want to see everything else. So you can customize it as per your needs, and whichever way you want to slice, just use the index position. You can use negative indexing also, or you can use positive numbers also. Let's say I write here, start at 3 and stop at 1. But remember, when you do this automatically, you will not get anything. Here you can see that you have got an empty list, empty series. Why did we get an empty series? Because by default, the step size is 1. When you're saying start at 3 and it goes and finds for index at 3, 4, 5, 6, and so on, because step size +1 will keep on adding your index position in every step. This stop at index 1 is not even found. Hence, you are getting an empty series. So if we want to make this work, then you have to give 3 colon 1, start at 3, stop at 1. When you are going in reverse order, like when in cases where your start is greater than the stop, in that case, you have to strictly give the step as a negative value. Only then you would be able to retrieve some data from there. Now I exactly got it in the form of D and then C, right? So there are few more ways in which we can do the indexing that we will watch in the next week. Thank you. Now let's explore Boolean indexing. You all might be knowing that Boolean is of like trues and then false, right? There are only two possibilities in Boolean, which is true and then false. Now let's say I want to filter my series. So first of all, I would just print my series. So here I have my series. The values of my series are 1, 2, 3, 4, and 5. I want to filter my series when whichever the value is greater than 2. Now, let us see how do I make that comparison. And when I write series greater than 2, this actually does element-wise comparison. Each and every element will be checked and it would be found whether it's greater than 2. When I run this, you can see that element-wise comparison is being done. 1 is greater than true, false. So I get false as my first index A. The second index label B. So B is actually 2. The value of B is 2. So 2 greater than 2. Again, it's false. So here I get false. And when it comes to the third, the value is 3. 3 greater than 2, true. 4 greater than 2, 5 greater than 2, true. So I get 3 trues and 2 false over here. As you can see, what here this greater than symbol does is element-wise comparison, and it gives true or false for the respective element. Since I have 5 elements here, so I have got 5 Boolean data. And you can also check the D type as bool over here. So as in this indicates the Boolean data. Now, how can I use this Boolean data for filtering my values? So that also needs to be taken addressed of, right? Sometimes we might also slice or filter our data based on some particular conditions. In this case, greater than 2. Now, let me write here series. As usual, how do you index? Open and close square bracket. Now, inside the square bracket, you pass on your conditional, like something that returns you true or false, right? So now I'm going to write here series greater than 2. Whichever gives series greater than 2 as true, only that useless. Now, in which cases I have got true, which is C, D, and then E, you can see that I got only the date as in which the filtering was true. Now, this is interesting, right? In whichever cases I actually got true, okay, this true Boolean indexing went over here. So the false indexing were ignored, and only in cases where the Boolean data returns true element wise, only those I get. Now we can use this logic even to extract even numbers in this series, right? So let's say we want to find even numbers in this series. So what I can do here, series index. Okay, again we can use index positions, and let's use Boolean data. So if I want to find whether whether a number is even, I can just divide it by 2. And if I get the remainder 0, then I can ensure that the particular number is an even number. So we have modulus operator symbol that we can use over here, right? So series percentage that represents modulus operator that divides and return as the remainder rather than returning a quotient. And then I want to divide it by 2 and get the remainder. And I am checking whether this remainder is equal to 0. So if the remainder is equal to 0, then it is clearly a even number. Now when I do this, you can see that I get only 2 and 4. Out of my series, I get only 2 and then 4. The same way, if I get the remainder as 1, then that means odd numbers, right? So when I write series indexed, I pass Boolean indexing over here. I write series percentage to either not equal to 0 or equal to 1. Both of these cases are true. So in this case, you can see that I am getting odd numbers over here, right? So I get 1, 3, and 5, which are the odd numbers that I have in my series, excluding the even numbers. So I would mention here odd numbers in the series, right? So this is how we can effectively use Boolean indexing to get and extract our data. Now we will discuss a very useful way of indexing, log and ILOG. So these are extensively used and very easy way we can apply the indexing way. Log is used for label indexing and ILOG is used for integer indexing, where we regularly use the indexing positions, right? So now let's start with log. Remember, these are not functions. These are just a way in which we can apply the indexing. So log is used for label indexing, right? So when I say label indexing, in whichever cases I have the labels, I can try to access the data with the help of the labels. So I will create one more series over here. I'll write series equal to PD dots capital S uppercase series, and let me create a dictionary, because that's easy for us to associate the respective index with the respective value. So let's say I want to create list of dictionary of students over here. The key is Amy and Mark 67, Krish, colon 88, and then let's say Zara, colon 45, okay, and Sana, 9, and Shiva, 92. So I have some students over here along with their marks. So as I have applied this dictionary, automatically the keys of the dictionary goes per index and the values of the dictionary goes as elements of the series, right? So here you can see that the data type is int64 and I have got the respective student's name as the index label. Now you all know that we can apply the indexing by using the like label indexing as well as the index position starting from 0. Now I'm going to explain about log and ilog. Let's start with log. So when I write series dot log, right, you just need to mention dot log over here and open and close square brackets, just the way how you regularly apply the indexing. Here also strictly have to open and close square bracket and it's not a parenthesis, right? Because we always do indexing with open and close square bracket only. And then let's say you want to find the mark of one particular student, let's say Krish. So I write here Krish. Okay. Now here I got 88. So now you might be wondering, why should I use log when I can directly use this without log also? Yeah, that's fine. But let me tell you why this is useful. Let's say I want to extract from Amy, okay, to Zara, right? From Amy to Zara. I want Amy, Krish and Zara. Remember what we have to do the same in case of regular label indexing without using log. You have to pass as a list of indexes, writing Amy, Krish and Zara, and then you have to do so. Imagine you have so many thousands and thousands of data you have. Will you be able to do that, give the label individually? That would be very difficult, don't you think? So how about we try to like specify, like, just like how we have range in case of numbers, we have start, stop and step. How about we try to apply that, though we can't do step here? Yeah. How about we try to mention here that let me start at Amy and stop at Zara. But remember, this is label indexing. So Zara will also be included. So now when I write series.log and then I mention Amy, colon, Zara, right? So over here, when I write this and when I run this, here you can see that I have got Amy, Krish and Zara. Now you can also use multiple indexing as well. When you want Amy and Zara alone, not like start from Amy and stop at Zara. And remember here stop at will also be included because it's not integer indexing. When it comes to integer indexing, your stop indexing will not be included. But here in log is exclusively only for label. Since even if you give integer as a label, it doesn't consider that as an integer. Log assumes everything as a label. Even if you give integer index over here, even in that case, when you give stop, right, that will be included when you are using log. Remember, log is different when compared to ilog, okay? And whatever the index may be, stop and stop both will included if you are using log. Let it be a string type, let it be an integer, whatever it may be. Right? Now, if I want to see Amy as well as Zara, only both of these people, then again, in that case, since you don't want to apply any series, then simply you just need to pass it as another list, just like how we regularly. Now you get Amy and Zara alone. Now the same way, if you want to like get every details from Krish to Sai, only log will accept Boolean indexing. Now I want to extract all those people who have scored more than 50 marks, right? So I write here series dot log. Again, you can pass a Boolean data over here, right? So series greater than 50, right? So when I index Boolean, here you will filter all the students who have scored more than 50 marks, which is Amy, Krish and Shiva. As you can see, those who have scored more than the 50 marks, 67 is Amy, 88 is Krish, okay, Zara, Sana less than 50, and Shiva is again greater than 50. So we get only these three students' name. The same way, if you want to, you can use equal to equal, whichever comparison operator that possibly gives you Boolean data true or false, that you can use for filtering, right? So now when I write series less than 60, those who have scored less than 60 marks, you can see here, which is Zara and Sana, those two details you are able to see over here, right? Now let's get started with iLook. So iLook is purely used for integer indexing, right? When I say integer indexing, I mean the index position. So here the index position starts at 0, and usually how do we apply start, stop, everything applies over here also. So when I write series.ilog index 0, here I cannot use strictly the labels. Here you can see that the mark of the first student I have got over here. Okay. So let's quickly see the series one more time. Okay, so you can see here the first mark of Amy is 67, and here we got only the 67 value. Then here also again I can use like say multiple index I want to extract. Yeah, again I can do that. So I can write index.ilog. Again I want 2 and then 4, right? So when I do this, here you can see that I will get Zara and Shiva, right? So index 2, it's not the second student, it's the student at index position 2. Index starts from 0, Amy 0, Krish 1, and then Zara 2. And then I've written 4 over here. So Shiva is at index position 4. So I get Zara and then Shiva. Then in the case you want to start from Zara and Shiva completely, since in this case here we have Zara, Sana and Shiva. 3 people are there in between Zara and Shiva. So again, you have to start using the start, stop, step kind of indexing. So here, series.ilog, let's say I simply write 2 columns. When I write 2 columns, I get Zara, Sana and Shiva. I get till the last student starting from Zara, right? But remember, if you try to do the same and mention here -1, Shiva will not get included. So you better leave it empty, because if you leave it empty, by default it starts at the first element and it goes to the last element. If start and stop leave empty. Okay, if both of these left empty. Next, let's try to take this from, okay, let me use this in this case. Now when I write series.ilog, right, I write here -1. If I write -1, I'm going to get only Shiva's mark, because Shiva's is the last student in my series, so I get only 92. Now when I write here series colon, okay, now I write, I'm leaving the start index empty. So when I leave the start index empty, you can see that Shiva is not included, right? So this column totally changes the way your data are getting changed, or how the data are getting updated, right? You can see that this are the different ways in which we can extract the data. So we saw the different ways of extracting the data, right? So the single data, you can directly either use the like index position, or we can also use the label index. We also saw how do we slice the data using start, stop, and step, right? So you can, the starting indexing will be 0 and stop at length of the data, and then step will be by default. And then we saw we can also use Boolean indexing, and we also explored log and then iLog as well, both of these things. Now that you would be thorough with how do we access data from the series in multiple ways, let's see how do we update and manipulate the data. Okay. So manipulating or updating the data in series, in Panda series. So now, if we quickly check our series, so currently we have these students in our series and along with the marks. Let's say I want to change the mark of Sana. Currently the mark of Sana is 39. I want to change it to 36, right? So what I can do, I can write series, indexed or square bracket, and then mention Sana over here, right? So I'm referring to Sana. So series index position Sana, and then just write equal to, just like how you assign values to the variables. The same way, what do we do here is we assign the values by directly referring to the index position. Now, when I run this, you know that this would return me 39, right? But I want this 39, in place of 39, I want 36. Just write equal to 36. This is label indexing. You could also use index position, let's say 2, for example. I want to change the mark of Zara. So the Zara is at index position, label index, sorry, index position 2, not label. So two things you can write Zara like this, or you could also use the label index, which is 2. And then let's say instead of 45, I want it to be 14. So this way also you can use. Now, till now, you would have observed that my series remained the same, right? Because extracting, slicing, indexing wouldn't modify the original series. You're just like after filtering, after accessing, the result only you get. The original series was not modified. But in this case, you actually modified the original series itself. Now, when I print this series, you no longer get the old values. Rather, here you are getting the newly changed values, right? In case of Sana, you get 36, and for Zara, you get 14. So you could also apply element-wise updations. For example, let's say I want to find CGPA of marks of all the students. So I can write here series divided by 10. And when I write this, each and every person's mark would get divided by 10. So instead of 6.7, I get 67, I get 6.7, 88, 8.8, and 92, 9.2, right? So you can check over here. But this wouldn't modify the original series. If you check here series, my original series is still in the same form only. Because if you want to modify the original series, you have to assign it back to the series itself. Now, when I write series equal to series divided by 10, and then I check my series, now the original series itself would have been modified. Now, when I run this, you can see that in the original series itself, I am getting the CGPA instead of the marks. Now, this does element-wise mathematical operation as well. This is how we can manipulate one by one, or if you want to manipulate on the whole, this is how you can do. Next, let's see how do we delete an element from series. Right? So, for deleting elements from series, we have a method called as drop. So, when you write series.drop, okay, and mention the particular label, right? So, let's say I write Amy. So, here you can see that I have got, except for Amy, I have got everybody's name. And did it replace the original or it returned me a new result? Actually, it returned us the new result only, because when you check the series, I again have Amy over here, right? Amy is not removed. But in this drop, what was actually happening is we were actually like returning a one more result, and it did not replace the original. Now, how do we replace the original? As you all know, what you can do two things you can do. You can write series equal to series.drop and then mention Amy or whichever person you want to drop, or if you want to drop multiple person, let's say I want to drop Amy as well as Sana. Remember, for multiple indexing, you have to pass on a list. Either you can do this, or I would always prefer in place equal to 2. So there is one parameter called as in place. So you can pass on the argument for in place as true. When you do this, you are actually replacing the original series. Now, after this, when you print the series, you will be able to see that in the new result, you no longer have your Ami and then Sana. Except for Amy and Sana, you get every other student's details. So with this, we are done with series. So right from accessing, manipulating and deleting, we have seen end to end. How do we create a series and how do we do multiple operations with series? In the next video, I will start with pandas data frame. Thank you. Hello learners. Now that you all learned about pandas series, everything about it, let's get started with pandas data frame. As you all know, pandas data frame is exclusively for two-dimensional data, the one with tabular structure that's having rows and columns. So, in order to create a pandas data frame, we use pandas dot data frame. And here, D and F are capitalized, right? Except for D and F, other things should be in lowercase, D and F alone in uppercase, right? This is how we create the data frame. And let's discuss about the parameters that are required for creating the data frame. So we have data, index, columns, D type, and copy. This is almost very similar to pandas series, right? Except that there is one additional thing here called as columns. If you remember, we have index in pandas series, and in pandas series, we had, since it's one-dimensional, we just had a one key for particular value. But now, since it's two-dimensional, we need to give some label for our columns as well. So hence, we have one more parameter called as columns. Let's discuss about this in detail. First thing, data. So data takes data in various forms, like say NumPy, ND array, right? We have series, panda series itself can be given as data, mapping data types like dictionaries, and list, tuple, constants also, and in fact, yet another data frame also can be given as data for creating our pandas data set. Just like series, here also we have index, and here also index is for creating our row labels. If index is not explicitly given, by default, it would take the range index that is starting from 0 to the length of the data minus 1. Next, we have columns. Now, as it is two-dimensional, we also should maintain a separate column label as well. So again, if no index is passed for columns, by default, index starts from 0. We have D type. So here we have to force the data type, right? If you are going to explicitly give, we are going to force it to make it all take one particular data type, right? But only one thing that we can give over here. So if by default the value is none, meaning it will be automatically inferred. I would recommend not to meddle with this data because enforcing everything to have a common data, provided if it's homogeneous kind of thing, then it's okay. But if each and every column is having different data type, then better not use this. Then we have copy. So here again, this is to copy data from inputs. One small difference here, if it is like a dictionary type, then the default of none actually behaves like copy equal to 2. If it were a data frame or a two-dimensional NumPy array, right? In case of dictionary, then copy equal to 2 is what none, the default value of none behaves like. Or if it is like a data frame or any NumPy 2D array, then in that case, the default of none behaves like copy equal to false. So we just need to be mindful of this as well when we try to use these things. Now, in summary, let's discuss what are all the different like input a data frame can take. So a pandas data frame can be created using various inputs, like we will see what are all the various inputs that it can take. First thing, list. But remember, list is a one-dimensional array. So we can give series also. Series is also one dimensional. I mean, list is like a one dimensional. Then we can give dictionary. Dictionary is permissible. And we can give numpy nd arrays, including two dimensional. Then another data frame as well. So these are the different ways in which we can create a data frame. So to start with, let me import pandas. If you have already imported pandas, there is no need to import it again. As you all know, the commonly used convention is .pd for alias name that we use for pandas. Let me store it in a variable called as df. So df equal to pd. Let's use the pandas library dot. Let's use the method called as data frame. Remember, like I mentioned, D and F in uppercase, right? Let me start with creating an empty data frame. Then I would write print df. Here you can see that it is actually printing empty data frame, columns empty and list index also empty. So here columns refers to the name of the columns, index refer to the row labels, right? Columns for column labels, index is for row labels. Then if I write type of df, here you can see that it is pandas.code.frame.dataframe. Again, it is from the pandas library itself. Let's start creating data frame from the different categories that we see. Create a data frame from list. So let me pass on a list of data, right? So let's say I give 11, 22, 33, 44, 55. Just a simple list I'm passing over here. df equal to pd dot data frame, and then I write here data. Again, the first parameter is always data. And then let's print the df. So this is what you get, right? As you see here, since list is one dimensional, in this case, I have just one single list over here, not list of list. List of list can be two dimensional. But as it is one dimensional, here you are able to see row labels automatically taking 0, 1, 2, 3, 4, and so on, starting from 0. And column label, again it also starts at, as you can see over here. We have two labelings given, row label as well as column label. Now, let's see what happens with list of list, right? When I write data equal to, now this time, I'm going to pass list of list, okay? So one more list here. And let this list takes two elements, okay? Name of a person and age of a person, right? So let's say I have a person called as Tom, and then I have a person called as Sam, okay? All this I'm passing as a list. So Sam age, let's say 26. And one more list I'm going to give over here, Jim, and then 25. So guys, this yellow color square brackets represents the outer list, right? And in the outer list, I have three inner list, which is Tom 24 is one list, Sam 26 is another list, and Jim 25 is another list, right? So this is the data that I have. Remember, here I have only three elements, okay? This is the first element, this is my second element, and this is my third element. So here, from the outer list, we have only three elements. So let's see how the data frame is being created. pd dot data frame. Let's pass the data. So now you can see that when you give a list of list, always it gives with respect to the element position. So just now I mentioned that we have three elements in the outer list. The first element is Tom and 24 list. And the second element is a list that contains Sam and 26. And the third element of the list contains Jim and 25. As you can see, as per the index of the list, here we have 0, Tom 24, okay, the outer, like with respect to the outer list, at index position 0, we have Tom and 24. Then again, Sam 26 and Jim 25. And here you can clearly observe that the column labels also starts at 0 and then 1. You can see 0 and then 1 over here. The column label is automatically taken as zeros and then 1s. So you have to be very mindful in this case. When you pass list of list, you're not getting it column wise, like in one column you have like Tom 24. Yeah. So you are actually getting this data printed row wise. Okay. So let me do one thing. Since as we don't have any proper like say column name over here, it's not nice. It's always good that we have a proper name for our column labels. For row, that's okay. Let it start at 0. But specifically for columns, it's good that we actually mention the column labels. Now, if I write df equal to pd.data frame data, along with this, I'm also going to use the columns parameter. And since I have two columns here, I have to strictly pass them. As you can see, the parameter name itself is columns, right? So I have to give a list over here strictly. Okay. And I have two columns. So I will be giving two values for it. Any sequence data type can be given over here. Then if I print this df, here you can see that instead of getting this 0 and then 1, here we are able to beautifully have a column label for our data frame. And it clearly says name and then age. So remember that this data frame with list of lists is created with each and every element of the outer list passing on as a row. Now let's see. Create a data frame from dictionary of list or ND arrays. Okay, either list or ND arrays, either which ways, dictionary of list, right? Now, I'm going to create a data equal to this time, as I've clearly written over here, dictionary of lists. Okay. So what I'm going to do here, I am going to give a key as name, okay, colon, and then value as list. That's exactly what I have written here, dictionary of list, right? Meaning the value given as a list over here. Now let's say I have two people, Vikram, Tara. Remember, in case of series, we had given the value as a single value, right? But in case of here, since it's two-dimensional, I'm giving the value as a list itself. Score, column, again, the value stands as a list. Since I have two people, right? So mark of both of these people, which is 87 and 92. Now, pd.data frame data. Again, here also, just like Panda series, the key of the dictionary is constructed as columns. One difference in series it was for row labels, but here, since column labels are more important, so here the keys of the dictionaries are constructed as column labels over here, right? And interestingly, the values of the dictionary are passed across columns, not like rows. In case of a list of lists, we are actually passing row-wise data, row 1, row 2, row 3, right? But here, in case of dictionary, you are going to pass column-wise data, right? Vikram Tara goes in column 1 and these two 87, 92 goes in column 2. There is a clear difference in both of these. And I would always like this approach because this approach is pretty comfortable and easy. So you can create a dictionary or a data frame in any which ways you want, right? So now I'll do a slight modification. Okay. I will take the same I will add one more person over here. Okay, I've added Akash and Mark, let's say I gave 90. Okay, let 87 be there. Yeah, so I have changed the marks a little bit. So here I have 3 students and then 3 marks. This time, when I give this, as you all know that I'm simply going to get 3 students instead of 2 students. Now, how about I also try to give the row labels? That would be interesting, right? If you don't give row labels, by default, it will start from 0, 1, 2. So no problem. We have the index parameter. Let's pass argument to the index parameter. Since I have 3 rows over here, I have to give a list of 3 values, right? So here, let's say rank 1, okay, and rank 2, and then rank 3. As per their mark, I am giving the labels. Now you can see instead of getting 0, 1, and 2, now I get the row labels itself as rank 1, rank 2, and rank 3. Next, this time I'm going to create a data frame from list of dictionaries. List of dictionaries, right? So I write here data equal to, remember I have mentioned here list of dictionaries. So list, outside it should be a list, and inside this I am going to pass on a dictionary. Unlike the previous case, in the previous case, okay, I had created a dictionary of list where in outer it was dictionary and list was passed on as a value. But now it's list of dictionaries. So over here, so first of all, I'm going to pass on 2 dictionaries, right? And in the first dictionary, let's say I have a key as A and then value as 9. And one more key, let's say B, colon 8, right? I have 2 key value pairs over here. And in the second dictionary, what I would do, I would again take A, okay, A colon, let's say 5, and then B colon 10. I would just give one extra, right? I would just write C colon 15. Okay, then PD dot data frame data. When I run this, here you can see that I have got A, B, and then C. But in case of C, it's NaN because I don't have C in my first dictionary. So it's missing. As you all know, we discussed about NaN. For it will be appended for missing values. So here I get NaN. But though even here I have 15 as an integer, it does type conversion or type cohesion with respect to column, right? It is not changing my other values, right? You can see that 9, 8, 5, 10 are as it is integer. Why only 15.0? Why not 15? Though I have given you 15. That's because NaN belongs to float type. So 15 as an integer was implicitly type converted to 15.0 to float. Okay. So hence I'm getting something like this. So you can see here that if you are having, let's say, some common columns and a little bit of different data, this is one more approach that you can use. And again, in all cases, your dictionary keys will be used as your column labels in case of data frame. And in any which case, your list, first element of the list would go in row. That is why you are able to see 9 and 8 over here in the first row. Second element of my list, right, goes in the second row, where you can see 5, 10, and 15, right? So this is exactly how it works. List data passed on as a row, each and every element giving row wise, whereas in case of dictionary, the value of the dictionary would be constructed across your columns, right? So this is the slight difference between both of these. And if you try to change one type, okay, for example, Imagine in case of 9, I have 9.2. Okay. Here you can see that though I have given 5 here, 5 also would be typecasted. See, I get 5.0 here and not 5. Just because here I have A as float, here I cannot have A as integer. Each and every column should be having the same type, whereas different columns, it's different. For example, in this case, A column and C column are float type, whereas B column is actually internal. All right. So now, let's say I use the same data. This time, I would choose a specific index. I would choose, since I have two columns, two rows here. So I would give two index values, right? So I would write here pd dot data frame and then data. Then I write index equal to, since I have two rows, I have to write here as a list first, comma, second. Here you can see that I have got the index label as row label, where I have first and second in place of zeros and one in case of the previous. Now here also I can select certain columns, what all columns you want. Let's say I don't want the C column, I want only A and B. So you can write columns equal to, pass on a list and write A, comma, B. So now here you can see that you get only the A and B columns. Now the same if I try to specify A and then Z, actually I don't have Z in my data at all, right? As you can see here, this is my data. I have only A, B and C's, right? But when I try to do it like this, here you can see that in place of Z, I get NA. So we have to be mindful while we select particular columns from the data. We have to ensure that the data actually exists. Now, one last way. Create a data from set of series. Right? How do we create a data frame from dictionary of series? Now let's say I have a dictionary called dictionary of series it is. So over here key is, let's say 1, right? And then value. In place of value here, I'm going to give a panda series itself. So I write here pd dot series. Okay, the data I will pass list as 1, 2, and then 3. And let me give my own index labels over here, row labels, A, B, C, right? Okay, 1, 2, yeah. So A, B, and C is what I have given here. Okay. And let me give one more value for my dictionary, comma. 2 is the second value of my dictionary. Sorry, second key of my dictionary. And second value is going to be another panda series. This time I would give 1, 2, 3, and then 4, right? And then index equal to, since I have 4 elements over here, I would write A, B, C, and D. So I have 2 key value pairs in my columns. So here you get 1.0, 2.0, 3.0 because in my second column, I actually have 4 elements. But in the first column, I have only 3. So that's not permissible. Here you get NaN. And as you get NaN, it belongs to the float type. Other 3 numbers are also got typecasted. And hence you are able to see this in float. 1 column is in float, whereas 2 column is in integer. Because here I have all the data presented. So these are the different ways in which you can create your data frame. Now that we have explored the different ways of creating a data frame, let's see in the next video how do we select or slice rows and columns from the data frame. Thank you. Hello learners. In the previous video, we saw how do we create data frames in various multiple ways. In this video, we will see how do we select or extract certain columns from a data frame. This is also called as slicing rows and columns. So, selecting or slicing rows and columns from our data frame, right? So, this is exactly what we are going to learn. Now, before I get started, let me create a data frame so that I can apply this for slicing. So, let me create employee data, right? So like I said, I would prefer dictionary of lists that's convenient and easy. So let's say data equal to name. The first column, I would like to have the name of the employees, right? So I'm creating a dictionary. So the name is the first key. And the values, since it's two-dimensional, I'm creating a list of values. So let's say J, Varun, Harini, Manu, right? So I have 4 employees over here. So next key, that's the second column, I give age. Okay, again I pass on a list. Let's say 27, 24, 22, 32. Comma. Next, address, Delhi, Mumbai, Chennai. Let's say I write Bengaluru. Then qualification, ME, MSc. Then I give MBA, PhD, right? So this is just employee data in dictionary. Now I want to convert this dictionary to data frame and I want to store it in a variable called as df. Df equal to pd dot data frame and then I pass on the data. So perfectly we have got our dictionary in the form of a data frame, right? So here you can all see here I have 4 columns: name, age, address, and qualification, and then 4 employees: Jay, Varun, Harini, and Pani, and their respective details. So every data row wise you can see the respective employees data, and column wise it belongs to a one particular same data. In this case, name, address, qualification are in object, and your age is an integer data type. Okay. So here, if you want to find the number of rows, you can use len of df. So when you write len of df, here the len returns the number of rows. Right? Number of rows in the data frame is what we can get. Then again, if you want to use indexing and slicing, there are 2 ways in which you can do that. If you write df dot, right, with the help of dot notation, you can see that all your column names are got recommended, right, along with methods. Here you can see address, age, name, and qualification. These are the 4 columns that we have. Now let's say I write df dot address, right? Remember, your index should be exactly matching, and when you are using dot notation, do not open and close quotation marks, right? Do not use quotation marks. Just mention dot address. That's it. Here you can see that individually each and every column of a data frame is a series, right? So each column of a data frame is a series. Then if you want to find the type of this, here you can see that it is belonging to the series type, right? So this is why each and every column should be homogeneous, but different columns can be of different type. And one more way in which you can extract data, you could also, as usual, use square brackets and then mention any of the columns. See, you have got name, address, age, qualification, everything. This time, let me choose name, right? And when you are using square bracket, it is important that you give the labels within quotation marks. Like if it's a string label, then we have to give that within quotation marks. Then I get one more series. Here you can see that each and every data type, each and every name of the person that we have, and the data type here is object, right? Jay, Varun, Harini, and Anil. And if you want to access multiple labels, again, here you can pass square bracket, and inside this one more square bracket, because here you have to pass a list of labels, right? Now I want to have name also, and then qualification also. So I want to have the name as well as qualification. So when I do this, here you can see that you have got the name and qualification. So we have name, age, address, and qualification. I have extracted only name and qualification, which 2 things that I want to see from this particular country. So this is with regards to labels. Now, let's start using the index position, meaning integer indexing. So whenever we want to use the index position, remember that again we have to use indexing based on start, stop, step. And here also the default value of start is 1 and the stop is the length of the data. Okay, and then we have a step, right? So we have step where the step value will be 1 by default, right? Start value would be 0. Sorry, start value would be 0 because it would start from the first element onwards. So the index of the first element is 0, right? So the element though start at first element, but its value, the index position is actually 0 only. Now, if I write df indexed 1 colon and then I leave other things empty. So here you can see that we don't get Jai details, we get only Harini, Varun, Harini, and Mani details because Varun is at index position 1. And if we leave stop empty, by default you will get till the last data that you have in the data frame, right? Then here, if you observe, the indexing happens for row wise. The indexing doesn't happen for column wise. I did not get skipped the first. I'm not starting from the first column here. I'm actually starting from the row indexed one, the row index position 1, right? I again get the same 4 columns. In my original data, I have 4 columns. Here also I have 4 columns because this is exactly how your indexing will work. Now, if you do not want the last element to get included, you could mention like say 1, start at 1 and then stop at -1. In this case, last row will not be included. So money will not be included. You get only Varun and Harini. And if you skip the starting index, right? Instead of writing 0 colon 3, so if you write 0 colon 3, Here you can see that by default it starts at the zeroth index position, and then here you get 1, and then because it stops at 3, the row 3 will not be included, row index position 3. Or you could simply skip this. You could just write column 3, but make sure you mention the column. And when you run this, here this is what you get. Right? It's exactly same. So you could very well skip start equal to 0, because if you don't mention anything, by default it would start at the same index position. Now, if I write df 0 colon 4, right? I want to stop at 4 and then I write 2, right? So here start at 0, stop at 4. Why 4? Because I have only index position 0, 1, 2, 1, 3. I don't have index 4, so I'm saying stop at 4. But this time I'm giving step as 2. If I do that, you can see I will be getting alternate employees starting from J, right? The same if I mention, actually this is same as colon 2. If even if you don't give start and stop, okay, still you will get the same result only. If you want, you can actually use, let's say, start at 1. Okay, stop, you give empty, and then you want to find alternate dates. Now you get Varun and Mani, right? So it's very simple. You could skip your start, stop, and step, provided the default value for start is 0, and for stop it is the length of the data, and then for step by default it is 1. So let me just quickly specify this. Okay. So start with 0, the same that we discussed in series as well. And in this case, it's the length of data frame, meaning the number of rows, and then step as well, right? So these are the data that we have. Now, I cannot use column for labels as in these labels, like something like I have my labeled columns I have. I cannot use this form of regular way of indexing. I can use this only for rows, right? I cannot use this for column labels. If I try to write, I want from, let's say, from age column to qualification column, I want to mention. So if I write here age colon qualification, okay, this would actually give me error. See, it says that it cannot do slice indexing on range index with these kind of index questions. So remember, you cannot apply this indexing, especially like if you have labels, you cannot apply this across columns. So if you try to do so, you will be getting error. All right. Now, how do I get this? We can see that clearly it's not possible. With the regular way of indexing, I'm able to extract rows. That's fine. How about columns? Don't we want to extract our columns as well? Now, this is exactly where what we are going to learn is something called as log. The same log that we had explored in series as well, right? With the help of log, what we can do, we can try to use label index. Okay. Now, when I say label, here we have two labels. I have row label also. I have column labels also. In that case, how can I use log? So, the log takes two types of index. One is across rows and the other is across columns as well. As in, I can use log to index for my row separately. That is row start, colon, row stop. Okay, comma. Then again the same for columns. Colon start, colon, colon, stop. That's it. Though might seem confusing, it's actually very, very simple. Once I start giving you the demo, in the previous case, you had only start and stop because it's what one dimensional in case of a series. But since it is a data frame, you have to give for start stop for row separately, comma, start stop for column separately. That's it. Okay. So let me just give a space over here so that it's pretty readable. Yeah, yeah, now it's better. Right? So we start at a row, we stop at which row, we start at which column, stop at which column. So let's quickly check our data frame one more time. So these are all what I have in my data frame currently. Okay, I have 4 columns and 4 rows I have. Now, if I write df.log square brackets, I want all the rows. This time we already saw how do we easily do row indexing. So I'm not going to do that. I will just put colon here indicating that I want all the contents of my rows. If you don't give any row start and row stop, automatically it will start at 0 and stop till the end. You get everything. Then when it comes to column start and column stop, I'm going to use my column labels. Let's say I want to start at name and then stop at address. Now when I run this, here you can see that I did not get the qualification column, and then you get perfectly everything from name to address, right? One thing that we have to notice here that here address also got included, right? So usually when we try to use start and stop, your stop index wouldn't get included in case of, let's say, integer indexing or when it comes to index position. But here, log is strictly for label indexing, be it row or column, and whichever type let it be, it applies for only the labels, right? So what do we get here is all rows and columns from name column to address column. And from here, very important thing to notice is that when it comes to log, the default start index was 0 because here you can see I kept it empty, right? So by default, it started at in the index 0 and end index is actually len of df minus 1, right? This is the default index. So default start index is 0 and the default index in this case of log is len of df minus 1. Unlike usually where we have only len of df, but here it's len of df minus 1. So why so? Because this is how we try to include that as well when we try to take the stop value, right? So now to make this understand clear, let me start applying my row label indexing as well. So this time I will use df.log. Okay. I will mention here 1 colon 3. Though this might appear like 1, 2, 3, so you might be thinking we get only index 1 and 2. This happens in case of regular integer indexing or index position based indexing. But here, even though this 0, 1, 2, 3 are actually index positions and it is integer, still it would be considered as labels only. So in this case, 3 also would get included. So let's say here I mention age colon qualification. Now you can see that I've got the age and qualification of the index position 1, 2, and 3 included as well. Right? So 3 is also included. The same way, again, if you want to check for name and address, we could also specify the name and address. So here, rows of index label 1, right? It's not index position. Here it considers everything as label only, right? And 1 and 3 included. Both are included in case of a lock. And additionally, I'm going to, since I have changed this to name, colon, address, and only name to address, column, labels, right? Or name, age, and address column labels, right? So only this we have got from here. So this is one more way in which we can understand this lock vector because it takes everything as label even if it is integer. So 3 also got included. Now let's say I change the index position. I write df equal to index. See, if you try to find the index, you can write df dot index. So here you can see that range equal start equal to 0, stop as 4 and step as 1. This is the default index that you get. Or if you want to convert this to a list, here you can see that currently the index that I have in our data are 0, 1, 2, and 3. How about I change this a little bit, right? Now I will give df.index equal to, since I have 4 employees, let me give row labels here as a string, right? So I give here employee 1, employee 2, employee 3, and employee 4, right? Then I will print my df. Here you can see that the row labels are changed. Earlier it was 0, 1, 2, and then 3. Okay, now this changed to E1, E2, E3, and E4. But if you try to do the same again, now that I've changed my row label strictly, I'm telling you all, this is not considered as a position. This is considered as label. So that is why I'm giving this much of examples. If you try to do the same, now that I've changed my row labels, it's no longer 1 and 3 in this case. When I do this, you can see that I have got my error, right? So why error? As index labels are no longer from 0 to 3 or no longer 0 to 3, right? I have changed this to E1 to E4. So it is currently E1 to E4, right? So I would just comment this so that you should know that here we should not give any sort of integer indexing in LOC or log. Now I would write df.log locate, or this is the good way that you could remember. This time I would correctly mention E2 from employee 2 to employee 4. This is row indexing from employee 2 to employee 4. Start from employee 2. And you also include, you end at employee 4. Then again, when it comes to column, name to address. 2 labels I have used over here. Now when I run this, here you can see that it is working perfect. I get only Varun, Mani, Harni, and Mani, right? Employees 2 to employee 4 also included. And all the labels that I have given for star and stop, both are getting included. Here also, just like series, here also, your lock can also accept Boolean indexing. Right? So, when I want to filter all the employees, employees whose age is greater than 25, right? And remember, this is a Boolean data, right? This is a Bool data because when I write index, when I try to find age and when I try to filter those who are older than 25, then this is going to be a Boolean data. Now I write here DF indexed age greater than 25. Since this individual columns behaves as a series, here you can find again the column wise comparison. For employee 1, you can see. So employee 1, the age is greater than 25. Yeah, employee 1 is J. So J age is 27. Yeah, it's greater than 25. And then we have Varun 24. So 24 is not greater than 25. Here you get false. Then 22, no, false. Then 32 for money, yeah. Employee for money, age is greater than 25. So I get true over here. I can use this for filtering my data frame as well. So what I need to specify here, just write DF indexed. And in place of the square brackets, right? So let me use log. Either without log also this will work fine. And yeah, log and then DF indexed age greater than 24. So when whichever employees, when whichever case is the condition is true, I am going to get complete details of the employee, not only like true or false things. Wherever true, where in which cases we had true. In case of employee 1, it is true. In case of employee 4, it is true. We actually get the complete detail, not only the age, with like completely whatever details we have in our data frame, everything is presented over here. And like I said, without log also this is possible. You can write DF square brackets and then DF indexed age. Let's say this time I try to find age less than 25. So here you can see that there are two employees age which is less than 25, Varun and Harini. Right? So this is all about log. With the help of log, we can try to extract with the help of the labels. Now, I will start with iLog. Again, iLog is used for integer indexing as an index position. Now, this is not based on labels. Here, this is strictly based on the index position. And just like log here also, for iLog, we have to give the rows indexing separately and then column like indexing separately, right? So both indexing we have to give separately over here. Now, if we quickly check what we have in our data frame, this is what we have. We have 4 employees and then 4 rows and 4 columns. Now, I don't have the index 0 anywhere here, right? If I write df index 0, here you can see that I am actually getting an error. It says it's not found. We get a key error over here, right? Because I don't have 0 neither in a row level or in a column level. So to avoid this, what we can do, df dot ilog index 0. When I use ilog, here you can see that we are getting the first row, right? We are getting the first row completely. Even though I have changed the label, you can see here I have changed the label now. My I have only indexing as label over here, which is E1, E2, E3, and E4. But how do I use integer indexing? I have to use ilog, right? If you use ilog, here you can see we have got the completely first row, J, 27, Delhi, and M. Here, name, age, name is J, age is 27, address is Delhi, and qualification is ME. So from this, you can clearly see that we are again getting a kind of a data like this. And here you can see the row index is being given as a name for this. Remember, we had name also in series. So this is how it looks. Now, how do I extract this Chennai? I want this Chennai. So if you want this Chennai, then again you have to use the integer indexing or index position of row and then column. So this is index position 2 because 0 is J, okay, 1 is Varun, and then 2 is Harini. So this belongs in the third row. So df dot ilog row 2, comma, and then column. Again, column is third column. So as per name is at 0 column, age is at column index 1, and then address is at column index 2. So when I write 2 here, you can see that I've got only Chennai, right? Now the same way, if I want this MSC, then again you can use df.ilog. Okay, so this is at the last column. So here you could first, yeah, this is a row. First, let's discuss about the row position, second row, and then we have at the fourth column. Okay, so second row meaning index position would be 1. So this is at index position 1. And column wise, it is at, since it's the fourth column, index position is 3 because the all the indexes start strictly from 0, be it row or column. Now, you can see that I have got my MSC, right? Now let's try to use slicing. How do I get multiple rows with the help of integer indexing? Now let's say I want to get maybe the first 3 employees. So I can write df.ilog again. Let me pass on the row index. Okay, I give 0, 3. You can see that I've got the first 3 employees, E1, E2, and E3. Right? So what did we get here? I get here I used only row indexing. I never used column indexing. Here I'm using only row indexing. So rows of index 0 to 2 and all columns. How all columns? Because I never used index position of my columns, right? When I give only one sort of start and stop indexing, I apply this only for rows, right? So now, if you try to do this df.ilog, and this time I will, let's say I want Varun and Harini alone I want. So index position 1, colon 3, right? Then comma, I write comma here. And then here I mention, I'm going to give my column indexing as well. So that because here I did not put comma, so by default I get all the columns. But now let's say I want only their name and then age, meaning the first 2 columns, right? So you can just write column 2. There is no need for you to write 0 column 2. You can skip it as well. You can just write column 2, or if you want, you can write 0 column 2. Both will give you the same result. Right? So what did we get here? Here we get rows of index 1 to 2 and columns 0 to 1, right? 0 and 1 column I got, and the index position I get from 1 to 2 because this is integer indexing. And remember that log and ilog are totally different. If you try to apply the same with log, you will be getting an error because log is label indexing. I don't have any numerical label in my data frame as you can see here. So when I try to apply this, I will indeed be getting an error, right? I would just comment this and then keep it like this so that you should know that in case of integer indexing or in case of label indexing, we have to use either log or value. Now, if I try to do the same, let's say just the same idea. Okay. So this time, let's say I want to use label indexing, right? Now, if I want to write df.ilog, and then let's say I want from employee 1, E1 to E3. So I want from E1 to E3 row indexing. And column indexing, let's say I give numerical data, or I also give, let's say, name, colon, address. Okay. So I'm using iloc over here, right? So I'm using iloc here. So when I try to use label indexing for iloc, see, we are getting error again, right? Now, I will try the same with respect to log, and you can see that it is perfectly working. So there is clearly a difference between log and iloc, and whichever is comfortable for you, that you can use, right? So these are the different ways in which we can use indexing and slicing. In the next video, we will see how do we add column, modify column, removing. All these we will see in the next video. Thank you. Now we will see how do we add or modify a column in a data frame. So adding or modifying a column in a data frame, right? So let's first check the data frame that we had created. Okay, so here we have the 4 employees with us, and we have 4 columns: name, age, address, and qualification. Now, if I want to add one column over here, then it's very simple. I just need to write df index or square bracket and the new column name. Let's say I write department. Okay, equal to, and let's say I give only one value, which is IT. So I don't have this department right now. So I just like how I refer to extract elements of columns by using this kind of square bracket indexing, the same way I'm trying to give a value for it. And when I print df, here you can see that one more column got added. And for everything, the value is IT. That's because I just gave here IT. If we want to have different departments for, like say, different departments for different employees, then obviously we have to pass a listing. Since we have 4 rows here, we cannot give a single data. Now, when I write df indexed department equal to, this time I will pass a list. IT, let's say I write HR. Okay, Varun is an HR and Harini, third employee, is the HR. And the 4th employee, let's say again IT, right? Now, when I print this, here you can see that row-wise department values was exactly in the order that I have given, matching with the current order that we have in our data frame. Now, if I want to modify a particular value, again, we can use any way of like extracting, slicing the data. I can directly use iloc, I can use log, or in which case I can use to get one particular like set of data that I want to extract. So now let's say I want to extract this particular person's degree, right? Like Varun's qualification is currently MSc. I want to change Varun's qualification from MSc to BBA, right? So modify Varun's qualification from MSc to BBA. So like I said, any type of slicing or indexing can be used. I would use iloc in this case because iloc is convenient. Like we are less likely to make any spelling mistake. In case of lock, we have to give the label, but in iloc, it's pretty simple. So here, this is what I want, and the row label, since it's the second row, my row label is 1, okay, comma. Column label, since it is at the 4th column, the column label is 3. So I write 3 here, and then I give the value, which is BBA. Okay, then let's print the data frame. So here you can see that in all these cases, we are modifying the original data frame itself, because when you use equal to, you are actually replacing or changing from the original data frame. So here you can see that in the earlier case, Varun's qualification was MSc. Now we have changed this to BBA. This is how we can try to modify a particular value. So if a particular column doesn't exist already, it actually created the entire column, which is because department did not exist already. But the same approach that you use to modify your data, right? Now that the department already exists, because we created department in the previous step, and then I am modifying each and every employee's department over here. And here also this particular row and column, this value already existed. I'm just trying to replace the value at the particular index position. So this is how you can approach, these kind of approaches can be used to add and modify your data. Now, very important part of data frame is filtering. So let's say I write filter columns in a data frame. You all saw that we can also use indexing, Boolean indexing, when we want to filter columns, right? So when I write df, right? So let's say I want to extract only IT employees from here, right? Over here, from here, I want to extract the employees, only those who are working in IT department. So what I can do here, index, again one more df, because I have to pass on a Boolean data over here for filtering. And then here I mentioned department equal to IT, because I want an exact match in this case. I want all the employees who is actually working in IT department. So when I check each and every employee, right, whose data matching with IT, remember that when you try to do this separately, you will be getting a Boolean of true and then false. And when you apply this for filtering, you get only the true data, right? So in employee 1 and then employee 4, only J and Mani are working in the IT department. Remaining 2 people, HR department, like we saw. Now let's say I want to extract people from IT department, but only those who are less than 30 years old. So 2 conditions I'm passing here. One is I want people from IT department only, and then age should be less than 30, right? So I'll mention here. Filter employees in IT department. Now this time, like I said, I need to give one more condition, right? Apart from this, and whose age is less than 30, right? In this case, we have to use one more conditions. In Python, generally we have and then or as logical operators. How do I use like add conditions, or let's say and the conditions, right? When you want to combine conditions, how do I do that in case of slicing? Yeah, there is an approach. So here, what I can do, again, I can take df index department equal to IT. Along with this, I need to also find whose age is less than 30, right? So I have to use and operator over here. And remember that in data frame slicing, strictly we have to pass on one condition within parentheses, right? If you miss that, you might end up getting an error, right? And one more condition is that df index age, okay, where age is less than 30, right? And what is the and symbol over here? Here, the and symbol is exactly like your AND logical operator of Python. Okay, so this is exactly like your AND logical operator. Now, when I run this, you can see that from the same above data, two conditions were satisfied. One is the employee working in IT department. Okay, so there are two employees, J and then Money, whose age less than 30. Money age is 32. So only J is less than 30. So you can see that I have got only my J. But remember, do not use this without, one thing you should not use and over here. Okay, this is wrong. You cannot use and in case of slicing. And one more thing, even if you use ampersand, imagine you are not using this parenthesis. Okay, even in this case, you get error. So remember that parenthesis has to be passed. Otherwise, you will be getting error. Okay. Now, let's try to use OR, logical OR operator. This time, I want to filter employees. Let's say who's working in HR department. Okay, either HR department or, okay, who is working? Yeah, in HR department or having PhD as qualification. So two things. One is either the person is working in HR department or the person is having PhD as qualification, right? In the previous case, it was and in this case, it is all. So DF indexed. Remember to use parenthesis, and this time I'm going to use this pipe symbol. Since I have two conditions, I'm using this pipe symbol. And what is this pipe symbol? Okay, this is exactly like or logical operator that you have in your Python operators, right? Now let's start giving the two conditions. The first condition, the department has to be HR. So DF indexed department equal to HR. Okay, it is or in this case, either HR or even if the qualification is PhD, then it's fine. So I'm trying to extract either department should be HR or qualification equal to PhD equal to PhD. So you can see that we have got two people who are working in HR department, though their qualification is not PhD, still we got it. And though one more person working in IT department also we got because at least one condition, the qualification is PhD. So this is how we can effectively use and or. And there is one more as well, which is a not operator. So now in this case, let's say I want to find all the employees who are not less than 30, right? Not less than 30. So in this case, there are different ways in which you can do. So when I use not operator here, the tilde symbol is like a not operator. And then I mentioned DF indexed age, okay, less than 30. Not over here, true becomes false and then false becomes true, right? So when I run this, you can see that it's doing otherwise. I actually get all the employees whose age is not less than 30, meaning greater than or equal to 30, but not less. So here, the tilde symbol is like not logical operator of Python. Okay. So this is how we can actually try to like filter the data in multiple ways using these kind of operations. Now let's see how do we delete columns in a data frame. So when I want to delete columns from a data frame, imagine I just add few more columns here so that it will be convenient for me to show the deletion. Currently, these are all the data that I have in my data frame, right? So I have from name to department. Now let me create one more column. So let's say I write salary column. Okay, so I'm going to give salaries. And like I said, it's not that always you have to give list only. You can give any sequence type like tuple also. So I write here 65,000 and let's say 35,000, 70,000 and 50,000. Okay, so I have given salaries over here. And let me create one more called as bonus. Remember, all these this element wise operations. Like when you want to give a certain like this kind of tuple kind of data, row by row, it gets passed. The same way, let's say bonus is 15% of salary. There is no need for me to manually calculate. I can let itself calculate because when I write DF index to salary, okay, and then I write into 0.15 because I want to calculate 15% of salary as my bonus. Okay, so bonus is 15% of salary, right? So what it does, it automatically does element wise, it takes 55, 35, 70, and then 50. It finds 15% of each and everything. Now when I run this, here you can see that it is perfectly calculating everything. Everything is automatically calculated. One thing I had given my own rows of data. You could also use existing data and do some calculation and store it as another column as well. Right? Now let's see how do we delete a particular, let's say, column. Okay. So I write here df dot pop. Okay, and then mention the column which is bonus. Let's say I want to remove the like bonus. Okay, one argument is mandatory if you going to use pop. And one thing about pop is that it deletes also and it also returns you what it got, what it actually deleted. Okay. So here pop, for pop you have to strictly mention what you are going to pop. Because usually in list and all, no, if you don't use anything, automatically last element will get out. But here it's not the case. Mandatorily give which column you want to pop. And also one more interesting about pop is that it not only deletes, but it also returns the deleted column. Yeah. One more way you can use del. Okay, del is a Python keyword and it's very, very effective. So when you write del indexed address, remember there is no parenthesis or anything. Del is simply a keyword, right? And when you run this, it actually deleted our address column, but it did not return. Unlike pop, pop actually returned you what got deleted column with the help of pop. And using del keyword, I removed the address column. Now without bonus and like address, here we have the remaining columns, remaining data. Now let's see how do we add rows. Right? We saw how do we add columns, modify columns, and delete columns. Now it's time to see how to add rows. Like I said, when you write len of df, you are going to get the length of the rows. Currently, I have 4 rows in my data, right? I have 4 rows and then 5 columns I have currently. Right? So now let's say I want to give one my row. So I can use lock or ilock, whichever you want. So I would use lock here because I want to give a label indexing. Currently it is E1, E2, E3 and E4. I want to give E5. So I am using lock here. And then I pass a list of the entire row, right? So let's say Divya, given the same order. First it is name. Okay. So then it is age, right? So in case of age, let's say I give 35. Then we have qualification. Let's say MS qualification. Then we have department, IT department. In the same column should be matching. And then salary, let's say 80,000, right? Okay. So now after I do this, I print my DF. So this is what you get. One more row got perfectly added. Yeah. And don't use iLock in this case. You cannot use iLock. Okay. Use only lock, right? As iLock will give error. You can try this with iLock as well. As cannot enlarge target object, right? So this is a useful way, and also other labels as labels like E1, E2, E3, and E4. I'd like to give it in this way. So we can also check what are all the index we have by writing df.index as an attribute. So when you write this, here you will be able to see all the index of my data frame. Currently I have E1, E2, E3, E4, and E5. And then you could also write df.columns to check the column names, right? Row labels and column labels. So here I have my column labels as name, age, qualification, department, and salary. So this is the easiest way in which you can add a row. Now, next part, deleting rows. Now we saw how do we add a row. How about we see how do we delete a rows? Let's say I want to delete E3, right? I want to delete Harini from my data frame. So how do I delete my row? You have to write df dot drop E3, right? And when you run this, here you can see that E3 got dropped. But did it replace the original? Till now, what and all we were using, actually few things replace the original, right? Mostly. But when you try to print df, you can see that it is not replacing the original. So if you want to replace the original, drop just returns one more a new result. It doesn't replace the original data frame. One approach, you can write df equal to df dot drop. This is one way. Or you could simply write df dot drop E3. And there is one more very, very important, interesting parameter called as in place. If you pass the argument as true for this particular in place, then what happens is in place equal to true means that you drop it and you replace the original. In place by default it is false. That is why in this case it was actually returning you a new result. A new data frame was returned. Original was not replaced. But when you give in place equal to true, you can see that it actually replaced the original. It's not returning you any copy. Now when I print df, now in the original data frame itself, I don't find my employee 3 anywhere. One more interesting way with drop, actually you can drop column also. So delete column using drop method. If you want to delete or like say drop any column using the drop method, then you have to use one more parameter called as access. So let's discuss what is this access. So when we want to speak about access, Access default is set to 0 only. So access 0 means that it would actually delete my rows, right? So when you write access equal to 0, right, you use this to drop rows. Okay, this is default. Okay, and then you give access equal to 1 to drop columns, right? This is how we can drop our rows and columns by changing the specific drop. Now, let's say I want to write df dot raw, okay, and I want to drop my age as well as qualification. So I write here age, and then I write qualification, right? But see, when I run this, I would be actually getting error because it says that key error, it is not found in access, meaning it is not found in row because I don't have age and qualification as a row label, right? So rather, when you try to give here access equal to 1, only then you are instructing your pandas to drop the columns. Now you can see that the age and qualification column was dropped, and this is what the remaining things that I get. With this, all the necessary and most important operations that we can do with pandas data structure, both series and data frames, are over, right? So now that this is over, so now we will discuss about how do we read or create data frames from various sources. Okay, thank you. Hello learners. In the previous video, we learned all about pandas data structures. We had a practical demo on creating pandas series and pandas data frame in multiple ways. We also saw how do we access the data. We explored slicing, indexing, updating, and deleting the data. Now, we will get started with how do we read data from various sources with pandas. Data analysis often starts with obtaining data from various sources. Pandas, being a versatile Python library, simplifies the process of reading and handling data from different sources. We will now explore commonly used sources one by one. CSV, comma separated values. So CSV file is a very, very popular plain text format for exclusively for structured data. And it is the most commonly used for data analysis and ML projects. So if we want to read files from CSV, we use this function pd.read underscore CSV. Here, each and every line represents a row and the columns are separated by commas. So these we name as delimiters. So the column delimiters are commas here, hence the name comma separated values. And then called Jupyter extension, like shown over here, so that you can start coding in IPYNB files. Okay, so I'll go back to the Explorer and let's create a new file. Pandas read from sources for IPYNB. Okay. And let me select a kernel. Right. So let's start with reading from a CSV file. So I'm going to load a file over here. Allow me a minute. So you can see here we have got user data.csv. So the first things first, we have to import pandas. Import pandas as PD. Then df csv equal to PD dot read underscore CSV and give the file name. Make sure that when you give the file name, you have to give the file name within quotation marks, be it double quotes or single quotes. And the name and the case should be exactly matching. For example, here I have user data, U in uppercase, then I have user underscore data dot CSV. You have to strictly give the extension as well, which is .csv. Right? Now let's see what do we have here. So this is how a comma separated file will look like. Here you can see that each and every column is separated by a comma. For example, user ID is my first column, gender is my second column, age is my third column, estimated salary is the fourth, and purchase is the fifth column, right? So this is how I have given various columns has been given over here. And each and every new line represents row. Okay. So always the first row will be your column header. So Pandas is smart enough that it actually reads the column header as a first row by default. So when we try to print this, this is what we get. So here you can see the column header is beautifully been arranged in a proper way. User ID, gender, age, estimated salary, and purchased. Like I said, this comma we call as a delimiter because that's how it limits or separates each and every column data. Right? And by default, any data frame, if we directly print, we always get first five rows and the last five rows. If we want to see only the first five rows, then we have to give df underscore csv dot head. We have to give the head method. Now with this, we'll be able to see the first five data, right? If you want to see the last five data, then you have to give dot tail. This is how we get. So here in this data, we can see that we have some users data or maybe customers. We have the gender, what gender they are, male or female, and they belong to certain age group. And what is their estimated salary and purchased zeros and ones. Though this looks to be number, it's a categorical data wherein whether the person purchased a product yes or no is what is given over here. So this is how we can try to read the data from CSV file. So now, next, what we are going to look at, we will see how do we read data from an Excel file. Here I have a data called a sample store, sample superstore.xlxx. So in this data, we can see that we have too many number of rows and columns, and this is Excel file. So I have an Excel viewer installed in my Visual Studio Code. Hence, you are able to see it in an appropriate way. Here you can see this perfectly in the form of Excel sheet, wherein you have the column being labeled as A, B, C, D, and so on. And rows are being numbered from 1, 2, 3, 4, and so on. So here you can see there are various columns. I have row ID, order date, ship code, customer ID, name, segment, country, city, state, postal code, region. Then we have product ID, category, subcategory, product name, sales, quantity, discount, profit. So these are the columns that I have in my data, right? Now that I have already imported pandas, there is no need to import it at every put. So df underscore excel equal to pd dot read underscore excel and mention the Excel name. So before this, make sure that you have the respective engine have got installed, right? So if we want to read from Excel file, we have to install certain engines. So let me mention the engine. So if you are going to install directly in Visual Studio Code, make sure you use %pip install. Otherwise, if you are using Jupyter Notebook or Colab, you can use !mark pip install, right? So the command is pip install open py excel, right? So this, what it does, this actually installs OpenPy Excel engine as it supports newer Excel files also, right? As like XLSX. Okay. Now let's start giving the file name. So I have here the file name sample. Yeah, see, it is getting suggested. Sample superstore.xlsx. Make sure to install this engine. Yeah, here we go. Here we can read exactly the same data, right? This is a customer data and it's order data actually, what customers are ordering which product and the complete information of it. So here you can see we have row ID and we have order date, ship mode, exactly what we saw over there. Everything is getting printed. Now, let's say I want to not see all the columns. I want to only view certain columns because as you can see, this is getting much bigger as we have 9,994 rows, almost 10,000 rows, and we have 21 columns, right? So this is indeed a huge data. Okay, so let me select few columns that I would like to read. So we can simply use the easiest way of indexing to achieve this. Okay, index, and I will have to give a list of labels that I want to give. So let me start with customer name. Okay, I think there is no underscore. Yeah, there is no underscore in any of the column names. Whatever it is, make sure you write it as it is. Okay, then I would like to take city, then maybe category, then subcategory, yeah, and subcategory, okay, it's capital C, right? Then maybe some numerical data sales, profit, right? So now I would be able to see only these columns, okay? So if you want to see some random data, right? If you use head, first five you get. If you use dot tail method, you will get the last five. But if you want to view random, you can use sample, right? So with the help of sample, you have to give some number, how many samples you want. And based on that, randomly 5 rows will be taken. Now let's say I give sample 5. So you can see the row numbers. It's purely random 1213 row labels. You can see 3096, 9274 and so on. And if I run this again, I get another data, right? So this is how we can read from a CSV file. Next, let's see how do we read from a JSON file. I'll load this data over here. Yeah. So now let us explore how do we read from JSON file. Like I said, JSON file is a very professionally used format. So here you can see I have employees.json. So here, like I said, it's pretty similar to Python dictionary, right? You can see it starts with square bracket and inside square bracket, so we have some bunch of curly brackets separated by commas. So all these defines one particular data, right? And here you can see ID colon 1, name colon Arvind, age colon 23, salary colon 56,000 or 56K. Then we have employee ID 2, Bhaskar, employee ID 3, Chandni, and 4, Dev, and then 5, Ivana. So we have these many employees of different age group and different salaries in the JSON format, right? This is exactly how a JSON format would look like. Now, let me add this. Read from a JSON file. So, pd dot store it, df JSON equal to pd dot read underscore JSON, and in goes the file, which is employees.json. And when I print this, all of these returns a beautiful data frame, right? You can see here, right from CSV, from Excel, whatever you get out of this actually returned a wonderful data frame. Now this looks very, very structured. JSON is actually a semi-structured data. And from the semi-structured format, here we can see it is perfectly in the structured book, like all IDs together, all the names together, ages together, and then we have the salary. So this is how we try to read file from the JSON file. Now, next part is reading from a HTML web page. Read from HTML web page or a website. Precisely HTML document. Okay. So I'm going to share you one link. You can see a Wikipedia web page here. It's a very basic one. The states and union territories of India, right? So this is how a web page will look like. In web scraping, we actually try to scrape tables or any useful information from this web page. So for that, we actually use developer tools of any that's given in any browser. This is a Google Chrome browser. You just simply right click and then you can see inspect option over here. This is available in any Google Chrome browser. And when you inspect, here you can see that we have got a table, right? And whatever you see on the right side are actually HTML elements, HTML documents, HTML source code. Based on this only, the entire web page is built. Here you can see the table element, right? So this table, when I highlight, you can see row by row, my data is getting highlighted. Yeah. And when I hover my mouse over the table element, the entire table is getting highlighted. Now, when I come down, here I have all my states in the first table, but I do have another table as well, where I have the union territories and all the capitals, right? So I would inspect this also. So here you can see we have got yet another table, right? So we have two tables in this web page. Let us see what happens if I try to read from this link. Make sure you copy this link. Okay. Yeah. Let's come back over here. So let me write, since it's all about India, I will write India equal to pd dot read underscore HTML, and I would give on the link. Okay, where is my HTML web page? That link I am passing. Now, if I try to print this, you can see that as we discussed, we actually get a list of data frames, right? So from read.html, what we get is returns a list of data frames as in tables, list of tables from the web page. Okay. So if you carefully observe, there is a square bracket here, which is clearly indicating a list, and the square brackets at the ends at the ends. Okay, I'll just open it over here. So this is what we got. Here you can see we have got a square bracket starting here, and at the end there will be a square bracket. So we have got like multiple tables over here. The first table you can see is where my states lies. And in the second table, I have the union territories, right? So if I want to retrieve the first table alone, not all the tables. If I want to retrieve clearly the first table, then I have to use indexing. Just like how we index our list, the same way here also we can index. Before that, I will show you that when I write type of India, you can see that I have got a list over here. This is exactly what I said. Now, I will write type of, India index 0, right? And then I would find this type. See, we got a data field. Now, this is exactly what I want. I want my first table here, right? So when I want to access the first table, I write wherever I have stored it and then use index 0. Here you go. Here you have perfectly got the table that exactly that we saw in the Wikipedia web page, right? So in the Wikipedia web page, we saw we had a serial number, states, capitals, and then codes. So here also you can see serial number, states, capital, and then codes, right? So exactly the row is also matching, right? You can see that we have got till 28 serial numbers. The number 27 that you see over here is just a row label, right? The row indexing is what you see here because the row indexing by default starts from 0. But as per the original table, we have serial number from 1 to 28 and 28 is the West Bengal. Now, here we do have one more table also, which is union territories and capitals, right? So this should be in the second index. Second table. So I write India indexed 1 because index starts from 0. There you go. Here you get region indicated in the map, union territory, capital, and code. Okay, exactly what we saw over here. And the region indicated in the map, A, B, C, D, E, F, right? So here you can see you got everything, E, G, F, H. And then we have the union territory names, their capitals, and then code. Perfectly, whatever is seen over there is perfectly visible over here as well. So this is how we read from the CSV file, right? If whichever table we want, that we can easily read. The next part, read from SQL database. So I told you that if you want to read from SQL database, first of all, we need to establish a connection, right? I will show you my MySQL workbench. So this is my MySQL workbench. And you can see that I can find all my details over here. So you can also like try to open the connection, edit the connection, right? You can find your username. So you can see my username is actually root only. I did not change it. And I have given one password. So based on this, I'm going to establish a connection. And when you click here, you can see that I have got multiple tables in my data. So my interest would be on the bank customers database, right? So this is my database name and the table name is customer churn. So in this customer churn, I have so many different columns. So just like how we write a query here in MySQL workbench, let's say select start from customer churn. So you can see you get all the data from the customer churn table. Now, the same query I'm going to code in my Python environment, right? And first of all, I have to establish a connection and try to retrieve this bank underscore customers database. And from this database, my interest would be to get details from this table. So let's start the coding. So first things first, import MySQL dot connector, right? If it is not installed, make sure you install it. Okay. Then database connection or DB underscore connection equal to MySQL dot connector. And from this, I have something called as connect. And with the help of this connect, I have to pass on all the details. If you look at the documentation, so here we can give whatever way that you can, like say, for example, use a password, right? The host, a database name, everything we can give here. So I'm going to give the username. So just now I showed you my username is root only. And next is password. Okay, password is very simple password I have given 1, 2, 3, 4, 5, 6. Whatever password you have given, the same that you have to use. Then name of the database, right? So name of my database, like I showed you, it is bank underscore customers. So I would write here bank underscore customers, right? And let me write my query here. Query equal to select star from my bank customers. I have a table named customer underscore chum. Okay, so this is my query, and let me store it in a variable pd dot read underscore sql. And from here, two things I have to pass. One is I have to pass on my query, and we do have the second parameter called as con. Con refers to connection, right? And I've already established the connection and stored it in the variable db underscore connection. Now this is what I'm going to pass on here. Now after I do that, let me write df underscore sql, and this is what you get. Exactly what I was getting in my MySQL workbench. We have customer ID, credit score, country, gender, age, tenure, balance, products number, credit card, active member, estimated salary, and finally whether the customer churned or not. Right? We have got the entire data after I establish a connection with my MySQL database. Now, the same way, we can also use other databases as well. Next part. Read from API. So, when you want to read from API, make sure you install the necessary library, which is request. It's requests in plural. Okay, so ESTS. Yeah. So if you're using Visual Studio Code, make sure you use percentage pip install request, or if you're directly want to install from Colab or Jupyter Notebook, use exclamatory mark, or in command prompt, you can directly write pip install request itself. So I'm going to first of all import request. Okay, after importing request, I'm going to work on an API, right, which I'm going to show you just now. So this is the API that I'm going to work on. As you can see here, the API is worldtimeapi.org. And you can see a kind of a JSON format over here, right? You can see that it starts with a curly brackets, and then we have a key colon value, right? I have a key called as abbreviation, and the value is IST. Because I have used here Kolkata from Asia, so we get our Indian time. And then we have the IP address, which is my IP address in which I ran this, I opened this API. And then what is the current date time, currently, which day of the week it is, what day of the year it is, all this information I am able to get, right? So I will copy this link. And let's start coding. Okay, now that I have copied the link, let me write response equal to request.get method. So the get method is what will pass on the HTTP request to the web page or to the API, right? Whichever we are working with. So when you try to print the response here, you can see that it shows response 200. 200 means it is successful, okay? Or you also have status code or OK. When you write response.OK, it says true, meaning successfully it was able to retrieve information from the request data, from the API link. Now, let's say I write data equal to response dot JSON because I have my content in the JSON format. So when I print this data, you can see that I get everything that I saw in the web page, right? Literally everything. But this is more in an organized way. Yeah. Whatever the information that I saw, I'm able to see here as well. Then, if we try to find the type of it, as I told you, the JSON format is actually pretty similar to our Python dictionary. You will be getting dict because it is indeed in the form of a dictionary type. Now, as you can see here, since it's a clearly a one-dimensional data, I can't create a pandas data frame from this, right? Because it's a one-dimensional data. I have only one key, and for one key, I have only one value. So if it were a two-dimensional, I should be having list of values for each and every key. For each key, I have only one value. So this is clearly a one-dimensional data. So I would create a series from this, right? So I would write data API equal to pd.series. And over here, I will pass on the data. Now when I run this, now we have converted this to pandas series, right? Then I can indexing with this in whichever way I want to index. Let's say I want to find the current date time or I want to find the abbreviation. So I can just write data underscore API dot or square brackets, and then if I write abbreviation, here you can see I have got IST. The same way you can try to get daytime also either with dot method or by this using the square bracket. So this is the advantage of actually storing this into series, right? You can see that if it is a series, like extraction and all will be very, very simpler for us. So I have got information what I am looking for. Now, if I want to do the same for multiple time zones, I have taken particularly for Asia and then Kolkata, right? So if you check in the link, I have here specifically chosen Kolkata. Now, how about I remove this? Okay. Now you can see the list of, here you can see a list clearly, list of all the time zones that are available in Asia. So Kolkata will also be here. If you just look at this, you see here is Kolkata, right? So similarly, you have all the time zones of Asia, not only India. So how about we try to retrieve all the time zones, right? So that would be more interesting, no? When we try to dig more information from this. So let me write time zones equal to, again, we have to use request module to get that information, request.get. Okay, and I will pass on the new link. This time I'm using only Asia. I'm not mentioning Kolkata over here. And make sure to convert this to JSON format because I want it in JSON only. So that I can easily, like once I get the data, I can easily convert this to whichever desirable format I want. Here we go. So here you can see we have got multiple time zones, right? So if you want to find the length of it, I mean, how many time zones you have, again, you can use this length function. Here you can see that we have got 75 different time zones in Asia. Now, I have to make it go to each and every link, right? Here I directly mentioned Kolkata. Here I directly mentioned Kolkata. But if I really, really want to get all the information that I'm looking for, then I have to use this link, right? Which is Asia from Almaty, Amman, right? Each and every part time zone I have here, I have to use all of this, not only Kolkata. So whichever will be the easiest way is indeed our format, right? So I will create an empty list called as Asia time zone equal to empty list. Then I would iterate a for loop for time zone in time zones because I have multiple time zones over there. Okay, then let me first of all store the link. right? As you can see, the link should not contain Asia because I already have Asia underscore over here. Sorry, Asia slash. So I will take only till this part, right? Because I already have Asia included. So, and from this, whichever is the time zone that I would be getting. For example, if you want to see the first time zone, you use index 0, right? So here you get Asia and Almaty. So the same way, each time the for loop runs, I want to get each and every time zone. So this is why I'm iterating in a for loop, and I'm like each time the loop runs, each and every time zone would be captured over here. I'm concatenating this time zone with my other part of the link, right? So when I print this, you can see we have got all the links. Amazing, right? We have got all the 75 links. Now, if we click on any link, it would work perfectly fine. But I'm not going to do that. I'm not going to give open and each and every link, and I don't want to manually do that task. We have request model to do that. So now let me write data equal to requests dot get link. Each time the loop runs, I am going to get each and every link data and I convert that to JSON format. And make sure that I have created my list over here. I need to append that over there. So Asia time zone dot append my data. So each time the loop runs one by one from Almaty, Amman till the last one, right, which is Erawan. All these time zones would be link would be passed over here, and request module will get all the data, convert it to JSON, and finally we are appending that to our list, which is Asia underscore time zone. I'll run this. You can see it is taking quite some time, of course, because there are too many data over there. So, amazing. So 75 links our request module has visited. Now, if I print link, remember link I'm not storing in a list. So it would give me the last link, right? Which is starting from the letter 1. So you can see the last one, which is error 1, we are able to see here, which means perfectly our link was captured. Then we will see what do we have in Asia underscore time zone. That's amazing. We have list of dictionaries. Very, very similar to JSON format. And this time, I not only have my details of Kolkata, I have so many different time zones as well, right? Starting from Almaty, you can see we have got all the time, 75 time zones. How to verify? How about we check length? Exactly 75. Exactly what I started from here. I have got 75 time zones. I mean the complete details. Not only the name of it, the link of it, the complete detail. Now it's pretty simple that we convert this to a data frame because this is already in the form of list of dictionaries. So I write df underscore API equal to then pd dot data frame. Let's convert this to data frame and I pass on Asia underscore times, right? And then df underscore API. Here we go. Here we have got the complete detail of all my time zones, all the 75 time zones I have. Here you can see clearly 75 rows and 15 columns because we had 15 keys in our data. Abbreviation, client ID, date time, day of the week, day of the year, right? And so many details we have. Okay. Or if you want to take sample, you can write dot sample. Let's say I want only 3 samples from this. Here you go. Randomly, 3 abbreviations and 3 data are chosen. So this is how we read data from multiple sources. So we started with reading data from a CSV file. and we read data from my Excel file, right? CSV file, this one, .csv, Excel file, .xlsx. Then from a website, okay, then from JSON format. Okay, so here we have JSON format. So from this JSON format, we read it from HTML, Wikipedia. So there in Wikipedia page, we had two tables. We got a list of data frames and we try to retrieve the individual data frames. Then we saw how do we read from SQL database. I established a MySQL connection by giving the username, password, the database name, and I wrote my query here, and thereby I established a connection and I was able to extract the table, read the table from them. Then from this API, worldtimeapi.org. So only Kolkata I read first, and then we got a one-dimensional data. So I made it as pandas series. Then I try to use the same logic and I try to get all the different time zones of Asia, and we try to read the same in data frame as well, right? So finally, we got this result. Okay. So with this, we are done. Thank you. Hello, learners. Let's learn the next module in our data wrangling course, which is data cleaning. Let's get started. What is data cleaning? Data cleaning is a fundamental process in data preparation. Data cleaning is also known as data cleansing or data scrubbing. It is basically the process of identifying and correcting errors and inconsistencies in the data sets. Usually, the data that we will be dealing with is raw. Actually, the data obtained in the original form is called as raw data. And the raw data is a set of information that was derived from a certain data entity to the data provider, and which isn't being processed yet by machine, not human. For example, some information gathered out of online sources to deliver deep insights into users' online behavior. And data is often messy. It would contain errors, missing values, some sort of inconsistencies, making this, the data cleaning, crucial for reliable analysis. Let's explore the benefits of data cleaning. So, clean data is easier to work with and is efficient for data analysis, as it reduces the need for data wrangling and extensive pre-processing techniques. This allows analysts and data scientists to focus on analysis rather than data correction. Also, when you're working with data from multiple sources, data cleaning helps in harmonizing the data, making data integration smoother and more effective. Data accuracy. So, data cleaning ensures that the information you're working with is accurate and reliable. By identifying and rectifying errors, you reduce the likelihood of making decisions based on incorrect data. Machine learning models trained on clean data tend to perform better. So, clean data reduces model bias and noise, thereby resulting in more accurate predictions and classifications. Better decision making. Clean data allows for more informed and data-driven decision making. With the confidence that your data is accurate and reliable, you can make decisions with greater certainty, right? Also, data visualizations are more accurate and insightful when created with a clean data. This enhances the communicative power of visualizations for reporting and decision making. Enhanced data quality. Clean data is a reflection of high data quality. When data is free from errors, inconsistencies, and missing values, it becomes a valuable asset for organizations. Data errors can lead to compliance issues, financial losses, and other risks. By cleaning your data, you mitigate these risks and reduce the chances of costly mistakes. Consistency. Data cleaning process such as standardization, normalization, all these helps ensure consistency across data sets. This is crucial for making meaningful comparisons and drawing reliable conclusions. In businesses where customer data is imported, data cleaning ensures that customers are represented accurately. This can lead to improved customer satisfaction and trust. So, on the whole, clean data simplifies reporting, allowing for generation of accurate, consistent, and reliable reports. So, data cleaning is not just a housekeeping task, but a critical step in data analysis process. It not only improves data quality, but also has wide-reaching benefits that positively impact decision making, risk mitigation, business operations as well. Clean data is an invaluable asset in an increasingly data-driven world. Now that we learn about data cleaning, next let's learn about handling missing values. Why should we identify the missing values? Missing values in a data set can significantly impact the quality of your analysis. Understanding why they occur and how to handle them is vital for accurate and reliable results. Missing values can result from various factors, including human error, data collection issues, or system limitations. Identifying and addressing these issues is essential for maintaining data integrity and a key factor in improving data quality. Let's see what are the strategies that we use for handling missing data. So in machine learning and statistical modeling, missing data can cause models to perform poorly or produce biased predictions. Hence, handling missing data is crucial for model accuracy. Also, as decision makers rely on data for informed choices, clean data free from missing values is essential and reliable for decision making. Now, missing data can lead to inaccurate analysis and misleading conclusions if haven't taken care of properly. Addressing missing values ensures data quality by reducing the risk of biased or erroneous results. Removing missing data. What are the pros? Data completeness, as in, when we remove rows with missing values, this ensures complete data for analysis. It also simplifies the analysis process, especially when the missing values are isolated cases. On the other hand, what are the cons is dropping rows with missing values results in reduction in data volume, which may lead to information loss or data loss. If missing values are not random and are related to specific factors, removing them could introduce bias as well. So in the given code, you can see that we have a pandas method called as drop NA. With the help of drop NA, we can remove rows with missing values. So with that, we can try to remove the missing values from the data. And in place equal to true indicates that the original data frame has to be replaced with dropping the missing values. Strategies for handling missing data. In continuation with that, we have imputing missing data. What are the prompts? Data volume. Imputation retains the data volume, allowing for more in-depth analysis. Right? We saw that when we drop missing values, the entire row will get removed. There might lead to some data loss as well. But how about we impute it with some reliable values? Thus, we retain the data volume. And it also maintains relationship between variables as well. Regarding cons, imputation error, meaning the accuracy of imputation depends on the chosen method and the quality of imputed data. Remember to select the appropriate imputation strategy based on the nature of your data and the context of your analysis. The choice of imputation method can significantly impact the results of your data analysis or model. So, let us have a quick revision on measures of central tendency. Measures of central tendency are statistical tools that help us describe the center or average of a data set. They are essential for summarizing and understanding the data. The three key measures of central tendency are mean, median, and mode. Let's get started with mean. So, mean, often referred to as average, is calculated as sum of all values in a dataset divided by total number of values in the dataset. Here is the formula. X bar equal to summation of xi divided by n, where x bar is the mean, xi refers to the individual point, and n refers to the total number of datasets. So over here, if you have a data set of ages, let's say 39, 34, 37, 35, and 33, to find the mean, we add all those numbers divided by 5 because I have 5 observations in my data. Then the mean that I get is 35.6. Next, we have median. Median is the middle value of a data set. So when the values are arranged in ascending order, for data sets with an even number of values, the median is actually average of the two middle values. Because if it's an odd number of data, then we could easily find the middle number. But if it is even, then we have to find mean of the middle two numbers. Here you can see the same example, the same data set of ages, 39, 34, 37, 35, 33. And when arranged in ascending order, we get 33, 34, 35, 37, and 39. So hence the median would be the middle number, which is 35 in this case, because there are two observations on the left and two on the right side. So the middle one is exactly 35. And if we have an even data set, something like this, 25, 30, 35, 40, then since I have two middle numbers over here, which is 30 and 35, we have to take average of the two middle numbers, which is 30 plus 35 by 2, and the median is 32.5. For distributions that have outliers or are skewed, median is often the preferred measure of central tendency because median is more resistant and robust to outliers when compared to mean. Here you can see the data set of marks with 100 and 327 as outliers. So you can see the data. So we have 139, 37, 327, 35, 100, 33. Well, all the marks are between the range of 30 to 40. Only 3 marks are very, very away from the range, which is 1, 327, and 100. First step is to arrange it in ascending order. And when we try to find the mean of it, we get 81.714, which is really, really good. Because of this outliers, my mean is drastically getting affected. While most of the students' marks are actually between 30 to 40 only, my mean is giving me an incorrect result. Whereas, on the other hand, the median is 37, which is perfectly justifying my data set. So hence, median would be the right choice when your data set has outliers. Mode is simple. It is just the value that appears most frequently in a data set. A data set can have one mode, which is called a unimodal, more than one mode, multimodal, or no mode at all if all values are unique. For example, if I have the data set of ages over here, the mode is 35 as it appears twice. Here you can see that we have 35 appearing twice while all the other numbers are only repeating once in the data set. Hence it is most frequent, that is our mode. And if we have another data set where 25, 30, 40 and 45, this has all unique values, hence this data set has no mode. So, in summary, the three central tendencies, mean, median, and mode, Mean provides the average value of the data set. Median represents the middle value or central point of the data set. Mode identifies the most frequently occurring value. These measures of central tendency helps us understand the center point of our data, making them vital tools for data analysis and decision making. So here you can see the imputation of missing values with mean is a common approach for numerical data. So given a numerical column from our data frame, and we use the pandas method fill NA for imputing missing values. And we try to impute it with the mean of the same column. Again, we use in place equal to true so that the original numerical column, the missing values itself are getting filled. Imputing with median is robust against outliers. So I have one more numerical column. Let's say it is fully consisting of outliers. In that case, median would be a right choice. Impute missing values in a categorical column with the mode as the most frequent category. So if I have a categorical column, I can use pandas fill NA method to fill it with mode of the given data. And here index 0 square bracket 0 is used so that I get the first item in my mode. Mode will be always written as a pandas series. The next part is dealing with duplicates. Let us understand why we drop duplicates. Dealing with duplicates is a critical aspect of data cleaning, ensuring that the data set is free from inaccuracies and bias, and that it accurately represents the phenomena that it is being analyzed. Better data accuracy and integrity. Duplicates in a data set can distort the accuracy of analysis. For instance, if you have multiple identical records for the same entity, the aggregated results may not reflect the true characteristics of the data. Improved model performance. In machine learning, duplicate records can lead to overfitting as well. A model may overemphasize the importance of duplicated data points, potentially causing very poor generalization to new unseen data. Minimization of bias and misrepresentations. Duplicates can introduce bias into the dataset. If a specific records are duplicated, they may disproportionately influence the analysis or model. This can lead to misleading results and conclusions as well. Removing duplicates reduces the data size, making it more memory efficient, and smaller data sets are quicker to process and analyze, leading to faster results. Better understanding of the data set. Data cleaning, including the removal of duplicates, leads to a clearer and more accurate understanding of the dataset. Researchers, analysts, and data scientists rely on clean data to draw meaningful insights. So, when dealing with duplicates, it's highly important to consider which columns we should evaluate for duplication. Sometimes, certain columns might contain unique identifiers, such as primary keys, that should be the basis for identifying duplicates. Additionally, you may want to explore the data further to understand why duplicates exist. Are they the result of data entry errors, system issues, or intentional replication? This understanding can inform the appropriate course of action as well. Let us now explore the strategies of detecting duplicate values. So we have a pandas method called as duplicated, With the help of this, we would be able to identify the duplicate rows in the dataset. So this method returns a Boolean series marking duplicated rows as true and non-duplicated rows as false. Here you can see df.duplicated is being applied. So this returns a Boolean series where the duplicated rows would be marked as true. So if you want to find the count of duplicated rows, you could add dot sum method as well. Along with the same code, you will be able to find the count. Removing duplicates. To remove the duplicates, we have a pandas method called as drop underscore duplicates. This method will eliminate rows with identical values across all the columns. Here you can see we can mention df.drop duplicates in place equal to true so that the original data frame itself would be replaced. Next, handling outliers. Outliers are the data points that significantly deviate from the majority of the data in the dataset. They can have a substantial impact on statistical measures and machine learning models. Predicting and handling outliers is essential for several reasons. Let's see that one by one. Maintaining data accuracy. Outliers can introduce noise and errors into the analysis. By detecting and dealing with them, one can maintain the overall accuracy of the dataset. Preserving model performance. Machine learning algorithms are sensitive to outliers, which can skew the model's predictions as well. So, handling outliers can lead to more accurate and reliable models. Ensuring fair analysis. Outliers can distort the results of statistical analysis, making them less representative of the general trends in the data or patterns in the data. So, removing or transforming outliers ensures fairness in our analysis. Now, we have two different measures, two most commonly used measures that would help us to detect and transform or remove the outliers. So let's see how do we detect outliers using Z-score. Z-score, also known as standard score, is a fundamental tool for identifying outliers. So Z-score actually measures how far a data point is from the mean in terms of standard deviations. So the formula consists of X, refers to all the data points in the data set, mu is referred as mean, and sigma is referred as standard deviation. And the formula is Z equal to X minus mu divided by sigma. Each and every data point has to be subtracted with the mean and then to be divided with the standard deviation. So we get Z-score for each and every data point. Z-score calculation. A positive Z-score indicates that a data point is above the mean, while a negative Z-score indicates that it is below the mean. So, we should not focus on whether it's a positive or negative number, irrespective of the sign, meaning magnitude or absolute of Z-score reflects how far the data point is from the mean. Be it above or be it below doesn't matter. So, one primary thing that we need to do is that we have to take absolute of Z-score so that irrespective of the signs of the number, we focus on the number itself. Thresholds. Researchers often use a Z-score threshold, either 2 or 3, to identify the outliers. Now that we will be finding Z-score for each and every points in the data set, in whichever data points we have Z-score exceeding the threshold value that we are setting, either 2 or 3, that based on that we will be considering the outliers, right? Whichever data point has Z-score greater than the threshold. And remember, here when I say Z-score, I mean absolute of Z-score. And the threshold is not like for the 2 is the most common one, 3 is the most common one. Actually, it would differ. It purely depends on the data set and kind of analysis that we are making. Now, we will see more about this. Before I start Z-score, let us first understand what is standard deviation. Standard deviation is a measure of how spread out or dispersed the values in a set of data are. It gives you an idea of how much individual data points differ from the mean or average of the dataset. A low standard deviation indicates that the data points tend to be close to the mean, while a high standard deviation suggests that the data points are spread out over a wider range. In a sense, standard deviation helps you understand the variability or consistency of the data. Like discussed, if the standard deviation is small, then the values are closely packed around the mean, indicating very less variability, right? And if the standard deviation is large, the values are more spread out, suggesting greater variability. So I have taken one example here. There are 5 students, A, B, C, D, E, and their marks given 85, 90, 78, 88, and 92. So the step one is we find the mean. To calculate the standard deviation, the first thing that we have to do is we have to find the mean. After all, because the ultimate purpose is to find how much each and every data point differs from the mean. So as you can see, the mean is sum of all values divided by total number of values. So sum of all the marks is 433 divided by 5, where we get the mean to be 86.6. Then in step 2, we try to find the squared differences from the mean for each value. That is, the square difference would be each and every value minus mean the whole square. So for each and every test score, you can see 85 minus 86.6 the whole square and 90 minus 86.6 the whole square. So for each and every test score subtracted by the mean, and here we have the difference. This is step 2. And in step 3, we find the mean of the square differences. So mean of the square differences equal to sum of square differences divided by number of values. So the next step is to add the sum of square differences divided by the total number of values. So here the square differences are 2.56, 11.56 to 29.16. So all these are added divided by 5 because I have totally 5 observations over here. So I get the mean of square differences to be 23.936. This is step 3. Then in the step 4, we take the square root to find the standard deviation. And it is as simple as that. So the standard deviation is square root of mean of the square differences. As in the square root of 23.936, which is 4.892. So the standard deviation of the given data set of the scores is approximately 4.892. So the steps that we need to keep in our mind are, first step is find the mean. Then the next step is to find the square difference for each and every value from the mean. Then mean of the square difference. Then finally square root of the mean of the square difference. Thus we get our standard deviation. So this is the formula for standard deviation. So we have two formulas here, one for population and one for sample. So let us first understand what is population and sample. As I have written here, population in statistics refers to the entire group that is the subject of study. It includes every individual or element that possesses the characteristics that are under the investigation. So, for example, if we are studying average height of all adults in a country, the entire adult population of that country will be the population. So, the parameters such as the population mean, which is called as mu, and the standard deviation sigma describe the characteristics of the entire population. Parameters are basically the measurements that we do with the population data. Then we have sample. Sample is a subset of population that is selected for a particular study. So the sample is selected from the population only. It could be selected randomly, and there are several sampling techniques also. So the goal here is to often draw conclusions about the population based on observations or measurements taken from the sample. So what happens in some cases, we would not be able to approach the entire population, right? The entire population might be extremely huge or not, it would be expensive for us to collect the entire population data, time consuming as well. So in such cases, if we take some unbiased sample and with the help of the sample, our goal should be to estimate the population. So the statistics, especially the sample mean, which is called as X bar, and the sample standard deviation, yes, are used to estimate the population parameters. Here, statistics are referred to the measurement that we do with the sample data. So in many cases, statistical analysis are conducted on samples due to practical limitations in studying the entire populations. So in summary, I can tell you that population encompasses the entire or the individuals, the entirety of the individuals or the data sets. Okay, that is relevant to the statistical limitation. While a sample is a subset of that population that is used to make the inferences about the population as a whole. Now, coming to the formula. So here you can see we have two formulas for standard deviation, one formula for population and the other one is for the sample. So for the population, you can see sigma is mentioned. As we saw, that is the parameter of standard deviation. And here for sample, it is S. And mu represents population mean and X bar represents the sample mean. So the formula is the steps that we did just now is we find the difference between, first we find the mean of the data, then we find the difference between each and every data point and the mean, then square it up, add everything and then divide it by the total number of observations. Finally, take square root of the entire data. This is exactly what we discussed in simple steps. Now, you might be wondering that we do have a different formula for population and sample. For population, we have n, and for sample, we have small n minus 1. So, the capital N indicates the total number of observations in the population, whereas small n indicates the total number of observations in the sample data. But why do we have minus 1 in the denominator? This correction is known as Basel's correction. This accounts for the fact that the sample data tends to slightly underestimate the population variability. So the rationale behind the adjustment is to provide a more accurate estimate of the population standard deviation when working with the sample. So using n minus 1 instead of the capital N helps to correct the bias that may occur due to the fact that we are estimating the population parameters from a sample and not the entire population. And this adjustment helps to better capture the variability present in the entire population. So now that it is clear what is a standard deviation, we will next start with Z-score. So here we have a data set 53, 58, 55, 45, 62, 47, 56, 52, 52, and 80. And this is the data set sorted in ascending order. So we discussed how do we calculate mean of the data set. So mean of the data set is 56 and the standard deviation sigma is 9.78. Once the mean and standard deviation is found, the next step is to find the Z-score of each and every data point. So here in the table, I have taken all the data points over here and I have subtracted the mean from each and every data point, right? X minus mu. So 45 minus 56 will give me minus 11 and 47 minus 56 would give me minus 9 and so on. As you can see, we have negative numbers also, we have positive numbers also. Then the Z-score would be X minus mu divided by sigma. In our case, the sigma is 9.78. So minus 11 divided by 9.78 would give me minus 1.13. I have rounded off to 2 decimal points. And likewise, I have calculated for each and every data points over here. Now, if we set the threshold value to be 2 as cutoff value to set the limit of outliers, From this data point, make sure that you take absolute of z to be greater than 2 is considered to be an outlier. Even if I have minus 2.46, that would also be an outlier in this data. So now, basically speaking, the z-score less than minus 2 or the z-score greater than 2 is considered to be an outlier. So in this data, clearly all my z-scores are pretty low except for 80. So 80 is the outlier in my data, but the threshold value too, because it is having z-score which is 2.46, which is greater than my threshold value. And yeah, it is pretty evident, right? So all my data sets are from basically from around 65, 45 to 60. And only I have 80, which is like way out of my data distribution. This is how we try to identify the outliers using z-score. Next, let us see how do we detect outliers using interquartile range, that is IQR. This is the second method that I told about. IQR method is an alternative to z-score for detecting outliers. So you may use z-score or IQR, any one method based on your choice and based on your data distribution. So IQR is particularly useful when dealing with non-normally distributed data. IQR is as follows, which is Q3 minus Q1. Q1 is the first quartile, which is 25th percentile of my sorted data set, sorted in ascending order. So when I have a data set with me and I sort it in ascending order, the data point that I get at 25th percentile would be my Q1. And Q3 is the third quartile, and it would be the data point which is at 75th percentile in my data set. And the difference between these two would be my IQR calculation. The IQR represents the range in which the center 50% of the data is concentrated. So our focus is to find the center 50%, which is actually the median of the data. And after finding the median, the data is furthermore will be having lower half and upper half. From that, we get the 25th percentile, which is Q1, and 75th percentile data point, which is Q3. IQR is less sensitive to extreme values than the standard deviation. Visualizing outliers. Data points beyond the range of Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR are considered to be outliers. Meaning, if a data point is less than Q1 minus 1.5 times IQR, and if a data point is greater than Q3 plus 1.5 times IQR, these data points are considered to be outliers. And whichever is in between these range are considered to be not outliers, which we can proceed to use for our analysis. Creating visualizations such as box plot can help in identifying the outliers. So for z-score, we can also use histograms as well. Before I start the interquartile range, IQR, let us first understand the difference between percentage and percentile. Percentage and percentile are both not the same and they are different. Percentage is a way to express a part of a whole out of 100. For example, if you score 80% on a test, it means that you got 80 correct out of 100 questions. On the other hand, percentile is a way to rank a particular score compared to all the other scores in the particular group. If you are in the 90th percentile in height, it means that you are taller than 90% of the people in the entire group. Let's take one example here. So I have taken some 10 students' marks over here, those who took a math test, and the total mark is out of 100. So out of 100, there are 10 students who scored the marks like 80, 90, 75, 65, 70, 55, 100, 60, 95, and 85. These are the marks of the respective students. So let's see how do we calculate percentage. So the formula for percentage is pretty simple and obvious. It is the mark scored by a student divided by the total possible mark times 100. For example, if I want to calculate the percentage for 90 marks, then that would be 90 divided by 100 times 100, which is 90%. So a score of 90 is 90% of total 100 marks, right? Let's see how do we calculate the same for percentile. To calculate the percentile, the first thing that we have to do is arrange the numbers in ascending order. So this is the original mark. So here you can see the numbers are being arranged in ascending order. Then step 2 is to count how many marks are below 90, because I am going to calculate the percentile for 90 marks. In the previous case, we saw the percentage for 90 marks, which is 90%. Now it's percentile. And in order to calculate the percentile for 90 marks, or generally the percentile, the number of scores below 90 or whatever score that you want to calculate the percentile for, divided by the total number of scores times 100. So in this case, as you can see in the step 2, that the scores that those who have scored below 90 is actually 7. As you can see, 1, 2, 3, 4, 5, 6, and then 7. There are 7 students who have scored below 90. So if I want to find the percentile of the student who scored 90, is I have to find how many people scored, or how many numbers are there that are below the given number, which is 7 in my case. Then that would be the number of scores below 90 and divided by total number of scores. We already know that there are overall 10 students in our data. So the percentile for 90 marks would be 7 divided by 10 times 100, which is 70. So this means that a score of 90 is in the 70th percentile of the entire data. This implies that the score 90 is higher than 70% of the scores in the entire given data set. So you can see the great difference between percentage and percentile here. So what we would be using in interquartile range is the percentile. I hope the difference is clear. Next, we will start IQR. Let us explore IQR, interquartile range, practically. So I have taken the same data set that we saw a few minutes back in the same set of numbers sorted. So now, when the data set is split into 2 halves, right, we get lower half and the upper half. So if I want to find the median, then I would be using the middle 2 numbers, which is 53 and 55 divided by 2. And I get 54. So 54 is my Q2. Median is my Q2. Then Q1, I have the middle half value of my lower half. So Q1 would be 52, right? Which is at 25th percentile. Median would be at 50th percentile. And in the second half, I can see the middle number to be 58. So 58 is my Q3 and 58 is at 75th percentile in the data set. So I can calculate interquartile range by using Q3 minus Q1, 58 minus 52, which is 6. And the lower bound, so I have to find a minimum cutoff point, right? So that is Q1 minus 1.5 times IQR. So when I calculate, I get 43. And the same way I find the upper bound, Q3 plus 1.5 times IQR, I get 67. So the values which are less than 43 and more than 67 are considered to be outliers. So clearly in the data set, I don't have any value less than 43, but I do have a value which is more than my upper bound, which is 67. So which is 80. Again, this also tells that 80 is the outlier in the data set. And this is how a box plot would look like. This is also called as box and whiskers plot. You can see that we have our Q1 over here and Q2, which is median, and then Q3 given in a box. And the difference between Q3 minus Q1 is what defines our interquartile range. Now, I am accepting some values less than Q1 and some values slightly greater than Q3. And that bound that I am limiting is this. So from my Q1, I go 1.5 times IQ to the left side. And from Q3, we go 1.5 times IQ towards the right side. Hence, you have negative sign for Q1 and positive sign for Q3 as given in the number scale. Now, this would be considered, the lower bound is the minimum accepted value and the upper bound is the maximum accepted value, which are considered to be not outliers. But if there is any data point which is less than the minimum and greater than the maximum like given over here, these are considered to be outliers. So this is how we calculate or we identify outliers using IQ1. Let's explore strategies for outlier handling. Once outliers are identified either using Z-scores or IQR method, one can employ various strategies to deal with them. First, removing outliers. What are the pros? It eliminates missing data, ensuring completeness. But the cons reduces the dataset size, isn't it? Since we are going to remove the outliers. This may lead to information loss. And another method is to transform the outliers. Rather than removing them, transforming them. What are the pros? Retains the data points, but actually reduces its impact. Cons may affect the distribution and relationships within the data. Transformations can include replacing outliers with median. In case of outliers with median value of the feature, if we have any outliers, then median would be the right choice. Mean, we could also replace outliers with the mean value of the feature. Clipping. We can actually cap the values of outliers as a predefined threshold. Whichever based on our data set, we fix our, let's say, set limits on our own. Based on that also, we can transform. Now, let's see how do we do this in Python using Z-score. Here you can see the score. We can calculate the Z-score. Let's say I have a data frame and I have a column called as value. So you know that the data, each and every data point has to be subtracted by the mean of it. So the DF index value is subtracted by the mean of the same value column. And then it is being divided by the standard deviation. So here I get my Z-score of each and every data points. Then I keep a threshold value, let it be 2 or 3, anything. So remember to find absolute of Z-score. Like I said, it's like the data point can be, like the Z-score can be negative or it can be positive also. But what we bother about the value alone. So in case the threshold is 3 and I'm filtering based on it, I keep the values within 3 standard deviations from the mean. So whichever is beyond that, I am going to remove it because I am filtering my data frame based on the Z-scores. So only those which are the Z-scores, absolute Z-score that are less than or equal to 3, only those data I am retaining. Other things have been filtered, removed. To transform outliers using Z-score, there are many ways in which we can do. One such way is mask method from pandas. So here you can see that I have taken the absolute of Z-score to be greater than 3. In whichever cases the condition is true, in those cases, my value would be replaced by the median. Otherwise, in cases where this is false, wherein the Z-score is less than or equal to 3, the original value from the value column would be retained. So, precisely what mask does is, it would check for the condition, and if the condition is true, it would replace with the given value. In my case, I am replacing this with median. Or if the condition is false, it would retain the original value that I have in my value column itself. So we also have where method. So that would replace if the condition is false. And we also have where method from NumPy as well. From pandas as well as NumPy. Using interquartile range. So I have quantile method that would give me the data point at a particular percentile. So if I mention 0.25, then I would be getting the data point that I have in my data set at which is at 25th percentile. So that would be my QP. Similarly, when I mention quantile with 0.75, then this would return me my data point that I have at 75th percentile in the data set. That would be my Q3. So interquartile range would be Q3 minus QB. The lower bound is Q1 minus 1.5 times IQR and upper bound is Q3 plus 1.5 times IQ. Once I found the lower bound, which is the minimum accepted value, and the upper bound, which is the maximum accepted value to be fit into the right range, beyond which it is going to consider as outliers. So here you can see that the values that are retained are strictly that are greater than or equal to the lower bound, and the values that are less than or equal to the upper bound. Only these two values are considered. And it is being filtered. The remaining values, which were not falling with these two conditions, are being removed from this data set. Next, let's explore data type transformation. In data analysis, data types determine how data is stored and interpreted. Proper data types are essential for meaningful analysis. For instance, integers are used for whole numbers, strings are used for text. Why data type transformation is required? Data consistency. Data sets often have data type mismatches where columns contain data in an incompatible format. It's important to convert data types to ensure data consistency and correctness. Data type transformations create a consistent and uniform data set, making it easier to work with, understand, and maintain. Data compatibility. So, current data types enable a wide range of analysis. For example, daytime data types allow time-based analysis, while converting categorical data to categorical data type makes it suitable for statistical operations. So over here, data analysis tools and algorithms often expect the data to be in the specific formats only. So ensuring the correct data types is crucial for the compatibility with these tools. Memory optimization. By choosing the most suitable data types, you can significantly reduce the memory footprint of your data set. This is especially beneficial when working with large data sets, as it can speed up operations and save storage space. Analysis accuracy. Proper data types enable accurate mathematical operations and comparisons. Incorrect data types can lead to incorrect results or error messages. So, transforming data type ensures the integrity of the data set. It makes sure that each column contains data consistent with its intended use, thereby preventing errors and misrepresentations. So, from this we can understand that data type transformation ensures that your data set is not only in the right format for analysis, but also optimized for memory and processing efficiency. It is a fundamental step in data cleaning, which is crucial for reliable and accurate data analysis. Let's now explore how do we convert different data types. Pandas provides methods like Aztec to convert data types. For example, converting a column of floating point numbers to integers, converting string or numeric data with limited unique values into categorical data types. From here, When we want to convert float to int, so converting floating point numbers to integers, if decimals are not necessary, we may do so. For example, converting a price column from float to int. Regarding categorical data represents data that is limited to a fixed set of categories or labels. Examples may be like colors, red, green, blue, or even some set of categories like a small, medium, large. Converting string or numeric data with this limited unique values, that maybe we can convert to categorical data types. Why? Because this exclusively reduces memory usage, speed up computations, and can improve performance. So sometimes when data is stored as object data type in pandas, that would also be converted to string to ensure consistency. Pandas provides the to_datetime method to convert string representations of dates and times into datetime objects. This enables date-based or time-based analysis and visualization. Actually, many datasets contain date and time information, such as transaction date, order date, ship date, even timestamps also. Converting date and time data into datetime objects allows us to perform operations like date arithmetic, filtering by specific time periods, plotting time series data effectively. Let's now explore common date type conversions. So here you can see I have a float column, and the float column can be converted to an integer column just by using df square bracket float column dot as type int. And we saw that the dates would actually be not passed as dates by default. It would be mostly considered as an object data type by pandas. If we want to consider the date to be actually a date, then we have to use pd.to_datetime and then pass on our date column. Now, our date would be parsed at dates itself. Now that we have learned everything about data cleaning, let's have a hands-on practical demo on this. Hello learners, let's have a hands-on practical demo on data cleaning using pandas. So let me add a title here as a markdown as data cleaning. So to start with, let's import pandas model and numpy as well. So now I'm going to create my own data as a form of dictionary, and then I'm going to convert this to data frame using pandas. And in my data, I'm going to deliberately include some missing values with the help of numpy np.nan. And then I'm going to deliberately include some outliers as well and some duplicate rows and stuff so that I can clearly show you a practical demo on how do we apply the data cleaning strategies like handling outliers and filling missing values and dealing with duplicates. All this we will see one by one. So here I have data equal to curly brackets. This is how we create a dictionary within curly brackets. And the dictionary takes key, column, value pairs. Each key of my dictionary would be considered as the column header. So here I have my ID. ID is my first column. And the values that I'm going to give is, let's say, 1. And then, like I said, I'm going to deliberately include some missing values. So np.nan. NaN stands for not a number. And then I have 3, 4, 5, 6. Let's say I give 7, 7, 8, 9, 10. Right? So I have some IDs given. And let the next column be age. Let's say I give 25, 30, 35, let's say 45. And let me include one missing value here, np.nan, and 30, 27, 40, 28, and 60. Right? Then income. So let's say income be 50,000, 60,000, 75, and my value 90,000, 62, and let's say 72K, 72K, and then one more missing value I would include. Then 55,000. I'm just writing some random data. 78,000. All right. Next, gender. So in the gender, let me give M and F values. So let's say male, female, and then I would give one missing value over here for categorical data. For numerical, both we have strategies to impute data with missing values. Okay, female, male, male, female, female. All right, gender done. Next, product amount. Again, I give my data over here. So since it's a data frame, I have one key to be my column headers, and for each key is having some bunch of rows with me. 150, 200, 180, 300, 50, 5,000. Let me give an outlier here, and in age also I've given 60 to be an outlier because most of the ages are pretty low in number. Okay, anyway, let's see how our mathematical formulas are able to perfectly identify the outliers. So here we can clearly see some outliers and missing values ourselves, right? But imagine we have bunch of data. We have 10,000 or millions of rows that we have. It would be highly difficult for us to find it manually. So hence these are very much essential. So here's my dictionary is done. I have created the data. Then let me store it in a data frame. So df equal to pd dot data frame. And here I will write data. And then let's print our data frame. So this is what I get. I have ID, I have age, income, gender, and then product amount, right? So if you carefully observe, though ID I have given as integer only, because of this one particular np.nan, which is considered to be a float type, all the columns, all the data of that particular ID column are being typecasted, right? Or it's been converted, everything has been converted to float type because it has to, each column is a panda series and it should have the same data type, right? So all my ID columns belongs to float type, no, just because of this NA. And similarly, it's the case with our age also, income also, and product amount also, right? Though we have given, okay, in product amount, I have not given any NAN value. So you can see perfectly it is taken as integer itself as per what I have given. But for the other two numerical columns, ID, age, and income, other three, we can see that type conversion or cohesion has happened internally, right? So this is what my data frame looks like. Now, let's see how do we handle missing values. Right? And first things first, let's see how do we check for missing values. So we have from pandas, we have a method called as isNA. So when I write df dot isNA, so this would return me a Boolean data frame, right? Because I'm checking it for a data frame where it would be completely informing me about each and every data, whether it is a null or not, whether true or false. So here you can see this is what I get, and you can clearly verify that in my ID column, second row is my NAN value. Here also you can see second row or row label or row index position 1 is true over here. But all my other data are false in ID. The same way in age also, you can see that age index, row index 4 and for income row index 3 and 8 or NAN. So you can see that exactly in that place only I have got true, right? In all the other places I have got false, right? And for product amount, everything is false because I don't have any null values in them. Now imagine I have a like too many rows for me to deal with. And getting a data frame of this Boolean data wouldn't make us any wouldn't help us in understanding how much null values we have. So what is the ultimate purpose is we need to count the missing values in each column, right? So count of missing values in each column. So before that, I would just like to highlight you one fact is that in Python, true is considered as 1 and false is considered as 0. So if I write true plus false, okay, this would do 1 plus 0 and it would return me 1. And the same way, if I write true plus true, right, we can do mathematical operations because true is considered as number. So 1 plus 1 is true. Having said that, now what I'm going to do is that I'm going to add all the true false values across each and every column. Thereby, I get the count of null values in each and every column because when I have one true in ID column, then it means that the ID column is having one null value. The same way in income, I have two trues. So true plus true would give me 2, right? Because false is 0 anyway. So it doesn't make any impact. So now based on this idea, I'm going to again try df.sna.sum, right? Dot sum, some method would add each and every column that we have in our data frame. So here we go. Here you can see that in ID we have one missing value, in age we have one, in income we have two, in gender we have one, and in product amount there are no missing values. Now, before we go ahead and proceed with any imputation techniques, remember I told you that mean is the most commonly used for numerical data, provided there are no outliers. If there are any outliers, then median would be the ideal choice. So before we try to find any sort of imputation, we should check for outliers. So let's check for outliers. So the easiest way in which you could check for outliers is through box plot, right? Again, in pandas itself, we have box plot. So when you write df dot box plot, so we will be able to plot a box plot for the data frame provided. This box plot takes few parameters. You can see here that the first parameter is column. So we have to give a column name for this. Okay, so here you can see we have column. And then font size, if you want, we can increase, and grid by default grids are enabled. If you want, we can give grid equal to false, right? And we can change the figure size. Once we give a tuple for the figure size, we will be able to reshape it, right? And this is what we have. So let me give only one thing, which is income. Okay, let's say I want to plot whether my income is having any outliers or not. Okay, so this is what I get. So let's say I don't want to see the grids. So it's very simple. I could just give grid equal to false. And I want to see it not vertically, I want to see it horizontally. So you have something called as vert. Again, you can give vert equal to false. So you will be able to see a horizontal box plot. So we exactly saw this in the previous video, right? I told you like how a box plot would look like. And this is our box plot. So you can identify this, okay, to be your Q1, okay, and this center line, okay, this is your Q2 and this is your Q3, right? So Q3 minus Q1 would give you your interquartile range, and this is your minimum allowed number and this is your maximum allowed number. Clearly, we can see that there are no outliers in my income column, right? Everything is perfectly fit And literally there are no outliers because there is no number which is less than the minimum accepted range, and there is no number which is greater than the maximum allowed range, right? So now if I want to check for other two numerical columns as well, I have checked for income now. Okay, we have age and product amount. ID, it doesn't make sense to do anything for ID, so I'm just going to ignore that. So let me take for ID, age and product amount. So if we want to plot multiple graphs at once, then it's very simple. Again, we have to write df.boxplot. This time, since I want to check multiple columns, okay, I write here age, and I also want to check for product amount, right? And I would like to give word equal to false because I want my box plot to be processed horizontally and I don't want the grid input. So one problem you will have, so when you try to plot multiple columns in one single place, you might not be able to see a clear graph, something like this, because the scaling would be done based on whatever is the maximum number. In age, I have in the ranges of very like less values I have between 25 and 60 and something like that. Whereas product amount is in the range of hundreds, and in fact, I have 5,000 as well. So because of this scaling, we might not be able to see it as clearly as we are able to see it individually. So this is exactly what I was saying. See, you are hardly able to see the box plot. That's because of this particular 5,000 value. Anyway, though we are not able to see a proper box plot, the scaling is done based on the bigger number. We can clearly see that there is indeed an outlier, right? You can clearly see our box plot is suggesting one outlier for after my age, right? And the same way, in our amount, product amount also, we indeed have one outlier. The circle represents the outlier. And this is our box plot. You can see the green line represents the median, which is Q2. And then I have Q1 and then Q3 and minimum maximum ranges we have over there. So this is box and viscous plot. So what is our conclusion here? From the above box plots, there are outliers in age and product amount columns, but no outliers in income column. So this is our observation. Now that we have found whether are there any outliers or not, now it's pretty easy for us to apply imputing, right? So now let's see how do we impute missing values. Now we checked how many missing values are there. We checked for outliers. Now it's time for imputing. So now that clearly income data doesn't have any outliers, so it's a good idea that we try to import our income data with the mean itself. Let's first try to find what is the mean of our income. So you just refer to DF square bracket income or DF indexed income and then just write dot mean. That's it. So if you use the mean method, it would return you the mean value of the income column. So here you can see that around 68,222 is our average mean income value, right? Now let's see how do we impute missing values with mean, right? And I also want to tell that this is a common approach. Strictly for numerical data, right? I would also mention that numerical data, because for categorical data, we can't find mean. Then again, I would refer to income. So DF indexed income and dot fill NA is the method where you will be able to fill it with missing values, right? So if you check the documentation of fill NA, okay, you can see that, one second, let it load. So fill NA, you can see we have value and we also have in place equal to false to be the default option. So what I'm going to do, I'm going to give a value that I want to replace the missing values with. And apart from that, I would also give in place equal to false, because if we don't give that, I'll show you what happens. So it would actually try to substitute it with the mean value that we have just calculated. Okay, we just calculated the mean value. The same I would write here. Right? And apart from this, if I run this, what happens is it would return me a copy by substituting the mean value. You can see that I had two missing values, and in both the places it's been imputed, right? So you can clearly see the row index position wherever true was there. Okay, in all these cases it's been imputed. But the problem is it just returned you a new pandas series. It did not replace the original, right? But all we want is we want to replace the original. So there are two things. One is you can write df indexed income equal to df indexed income dot fill in a, or you can use lock, or you can directly use in place equal to 2. This would be the easiest way, so that you are replacing the original column itself, not returning a copy. That now it's been imputed. So next, well, let's try to impute. This time I'm going to impute with median, because this is robust against outliers. Okay, so since I have outliers in both my age and then product amount column, so I'm going to write df index age dot fill in a. So I'm going to fill my age with my median, right? So let's do that. Dot median, right? So just like dot mode, you have dot median method to help you find the median value. And make sure here also you give in place equal to true. The same way, I would also take my product amount column as well. Dot fill in a. Again, let's take the same column. Dot median. Okay, and in place equal to 2, so that the original column data frame or the particular column has been replaced. Amazing. Now let's try to check whether these are having any null values, right? So what you can do, you can particularly check for this particular column, or you can check for all the columns. Okay, I'll do one thing. Now that all the numerical columns are done, okay, let me try to do the same for my gender also. So gender is a categorical data, right? So if you see dot df index gender dot value underscore counts, you will be able to see the unique values that we have in our data, which is in our data, I have 6 females and 4 males, right? So from this, you can clearly see that we have maximum number of females in our data when compared to male. So mode is nothing but the maximum occurring or most frequent category, right? So if I want to find the mode, I can just refer to the column name and just write dot mode. But the thing is that our mean and median returned a one single value, right? So if I wanted to find the median of my age, okay, I got a one single value. And the same way here, if I try to do this for my mode, what happens is that I would not get a one single value, because a data frame or a series can have, let's say column wise, let's speaking about a series, okay, can have one mode, it can have more than one mode, or it can have no mode at all. So always it would return you a series if you are finding mode for a series, or if you're finding it across a data frame for each and every column, so you would be again getting a data frame of modes. We can clearly see that F indicates that F is the most frequently repeating number. But as you get it in series, we cannot try to impute it, right? So our fill and a methods expects a direct value, doesn't expect a series over there. So in order to avoid this, what we have to do is we have to use this index 0 so that we will be getting the first occurrence, right? So when I run this, here you can see I get only F. So this is what we have to get. We have to get the direct value. Now, impute missing values in a categorical column with the modes. Okay, and what is mode? Mode is the most frequent category, right? And let's select our gender. So df index gender equal to, okay, this time I am using equal to, right? Like I said, either you can use fill in a or you can use equal to also. In any which ways, it will work exactly the same. So fill in a, and I want to fill it with mode of my gender column, right? Dot mode. Remember, don't just write dot mode. You have to specify a perfect value. So you have to use index 0 over here, right? So now I run this successfully done. And we do have one more NAN left. Okay, we dealt with age, income, gender, product amount. Already we don't have any missing values. So something that still has NAN is actually our ID, right? So we still have ID. But what I'm going to do, I'm simply going to drop the NS. Remember, do not drop it in the beginning, right? So ID, it really doesn't make sense that if I try to like impute ID with a mean or median or a mode doesn't make sense at all because this looks to be like a primary key. So it's better we drop those particular things, right? So if it doesn't make any sense or it's only one thing that you could just ignore. So what we can simply do is you can also use drop method. So the choice of dropping or keeping is purely based on the criticality that you have in your data set. Okay. That decision should be made with careful efforts. Now, dropping rows with missing values. So now that I have like done with every other thing, like every other column I have already filled in with missing values, you can see I have imputed my income, I have imputed my age, product amount, and gender also, all the imputations done. For remaining one is ID only. Like I said, I'm not going to impute anything. I'm just going to write df dot drop NA. So drop NA, what it would do, it would drop all the like particular row, wherever missing value is there, the entire row would be dropped. And make sure you give in place equal to true. Otherwise, you would just return a copy. Done. Now I'm going to check it again. df.sna.sum. This time, or everything should be 0 and it is 0. Now you can see that I have 0 null values in my ID, 0 null values in my age column. Income, gender, product amount, I have literally like gotten rid of all the missing values, right? I had these many missing values. Now I don't have any sort of missing values, right? You can also see it by printing it. Yeah. So remember that this so many decimal places was included just because of this, because when we try to input it with the mean, no. So what happened is that we try to get so many decimal places, right? So because of this, so don't worry, we will do the conversions and we will round it off together. That I will demonstrate. So for now, let's try to, and you can see that ID when wherever it was in AN, that particular row was removed totally. Now we have one data with us, right? So conversion from one type to another type also we will do. So now next thing is removing duplicates. Now that we saw how do we impute the missing values, we do have some duplicate rows over here. Like I told you, I have deliberately given, like say the 7, 7, right, 27, 27, two values to be exactly matching. You can also find here in this data, right, the index label like 6 and 7, you can see it's exactly the same, right? So let's see what happens. How do I find whether how many duplicate rows I have? I have to write df dot duplicated. So this would return me a panda series because it is checking row wise only. For each and every row, it would check and then it would give me true wherever there are any duplicate rows. So here you can see that when it comes to row number 6, I did not have the row number 6 earlier. But when it comes to row index 7, I did have exactly the same row as similar to my row label 6. Hence, it is giving me true over here, right? In row index 7. Now, let's try to find the count. Like I said, this is a simple data, so you're able to clearly see everything. But in actual, when you work with the real-time data, no, it will be highly difficult for you to look at the Boolean series or whatever. So you have to use dot sum method, just like how we did df.sna.sum to find the count of missing values. Here you would be able to see the count of duplicated rows. So you can see that we have only one duplicated row. So how do we drop it? Very simple. You just write df equal to df dot drop underscore duplicates. That's it. Right? So when you use drop underscore duplicates, I just want to show you the documentation. Okay, so here you can see that we have certain parameters, and here also we have in place equal to false as the default. So if you are giving in place equal to true, then you don't need to store it in a variable. Since I'm directly using df equal to, I'm continuing with the same. Then after dropping the duplicates, this time when I try to find df dot duplicated dot sum, it has to be 0. Let's cross verify that. And yeah, it's exactly 0, meaning we have totally dropped the duplicate rows as well, right? So two things done.